are proud to help bring you TV 12's news programming. This week, join Jacques Cousteau and the crew of the Calypso as they rediscover the mystery of the Marquesas Islands.
Once upon a time, while he was fishing, the fabulous god Maui pulled the Marquesas Islands from the deep.
Join the exploration, Cousteau's rediscovery of the world, tonight at 9 on TV 12. It's back, The Hitchhiker's Guide to the Galaxy, Sundays at 11 on TV 12.
Weeknights, do it yourself with TV 12. Mondays, it's a new season of The New Yankee Workshop. Tuesdays, it's a new TV 12 production, Furniture on the Mend. Wednesdays, join Dean Johnson and Joanne Liebler for a new season of Home Time. Then on Thursdays, it's Louisiana Cooking with Justin Wilson. Do it yourself. Weeknights at 7:30 with TV 12 beginning Monday.
Hello there, Harvey here, as in Harvey in the Morning from Magic 103. All of us at WMGK are proud to join you in supporting the fine programs here on TV 12. So settle back and enjoy, because here comes another one. See ya.
For generations, people have wondered about the Earth. Could our world once have been bombarded by meteorites like the ones that cratered the surface of the moon? Were dinosaurs the victims of a latter-day meteorite impact that caused mass extinctions? Could meteorites strike again and bring about a great cataclysm? Join us in a search for the meteorites that have shaped our world. They were here at our planet's birth, and they've left clues of their return. The third planet from the sun, this time on the Miracle Planet.
Funding for the Miracle Planet was provided by Bull Worldwide Information Systems, unleashing the power of computers for customers on 5 continents.
And by Amoco, fueling the American dream for the year 2000 and beyond. And by viewers like you.
Hello, I'm Bill Curtis for the Miracle Planet. Billions of years of history have brought us to this moment. At any point along the way, the development of the Earth might have been diverted to follow a different course. Considering the odds, it's miraculous the Earth did not develop differently, becoming a blazing inferno like Venus, or a frozen desert like Mars. Our planet is a world of vast and intricate systems of astonishing extremes. Dense forests and barren deserts, volcanic heat and glacial cold. The Earth is teeming with 1 million forms of life that have helped shape the very nature of our world, from the land under our feet to the air we breathe. In this series, we'll explore the unique combination of events and forces that have formed our planet and continue to shape it today. This huge crater in the heart of the Arizona desert is evidence of the power of these ancient forces. It was caused by the impact of a meteorite, a rocky fragment from space. These travelers through the universe hold a key to understanding how our world was formed and what our future may hold. In the middle of the Pacific Ocean, the snowy peak of the island of Hawaii rises above the clouds. This is Mauna Kea, the White Mountain. From the dormant volcanic crater on its summit, we can look down on the clouds gathered below, or up into distant galaxies. At sunset, the horizon seems to extend forever. In fact, the high altitude of Mauna Kea and the clean mid-oceanic air make it possible to view the heavens with particular clarity as the high clouds dissolve in the evening sky. Yet as beautiful as it may seem, the sunset is just the prelude to the real show. Almost every night, the great doors at the Mauna Kea Observatory roll open, and some of the world's most powerful optical telescopes are turned on the night sky. Tonight, the telescope scans the surface of the moon. As early as 1826, the German astronomer von Grothuizen proposed that lunar craters were the result of meteorite impacts. But his credibility was undermined because he also proposed that other lunar features were built by a race of moon creatures he called selenites. In more recent times, the images from sophisticated telescopes and space exploration have led to the wide acceptance of the meteorite impact theory. During the last 2 decades, space probes have brought back evidence of tremendous meteorite cratering throughout the solar system. Craters were discovered on Mars and 2 of its moons by NASA's Mariner probes between 1965 and 1971. Images of Mercury from the Mariner 10 mission show the planet closest to the sun. Like our moon, Mercury is scarred with meteorite craters. The Voyager probe revealed a huge crater on Mimas, one of the satellites of Saturn. And on Enceladus, the ice-covered satellite of Saturn, the frozen surface is marked with thousands of meteorite craters. The numerous craters on the moons and planets in our solar system raises a basic question. Where did all the meteorites come from? A search for this answer leads to more fundamental questions and theories of how our solar system came into being. No one can be certain of what happened more than 4.5 billion years ago, but many scientists now believe our solar system was born when dust and gases began to coalesce into a very hot disk. The center of the disk grew increasingly dense and bright, giving birth to the sun. Around the sun, other solid bodies formed, including an enormous number of planetesimals. They contained the raw material of the planets and ranged in size from a grain of sand to much larger protoplanets, several miles in diameter. According to one estimate, there were more than 100 trillion planetesimals in our solar system. Sometimes they collided, Upon impact, some planetesimals fragmented. But more often, they combined to form larger aggregate bodies. Over millions of years, these young planets continued to grow, collision by collision, to nearly their present size. As each one of the protoplanets grew in mass, the increase in its gravity attracted more of the remaining rocky fragments that crashed to the surface. This is how Mercury was formed, and Venus, and Mars. This is also how the Earth was formed. At an early stage, the Earth was pockmarked with craters as meteorites rained down on its unprotected surface. The scars of those ancient meteorite impacts are still visible on the surface of the Moon and other planets. Most have long since vanished from the Earth due to weathering and the continuing geologic development of our world. But evidence remains of more recent collisions of large meteorites with the Earth. In 1904, the first identification was made of a meteorite crater on Earth. The crater lies in the Arizona desert. David Moreau Barringer, a mining engineer, found meteorite fragments and sedimentary deposits that eventually led to dating the impact at between 25,000 and 50,000 years ago. The Barringer crater allows us to explore the kind of craters we see on the Moon and marvel at the power that could create a giant crater like this in the batting of an eye. The meteorite that formed the Barringer crater was probably no more than 100 feet in diameter. Yet it left behind a crater 3/4 of a mile wide and 640 feet deep. Since Barringer's discovery, more than 100 terrestrial meteorite craters have been identified. They occur in all parts of the world, but are particularly impressive in northern Canada. This ring-shaped lake is the scar of a meteorite impact long after the birth of our world. Across the terrain, the shapes of other craters are still discernible. One of the largest and oldest craters lies on the west side of the Ungava Peninsula in northern Quebec. First identified from aerial photographs by a prospector in 1950, the new Quebec crater is over 2 miles wide and 1,200 feet deep. The action of Ice Age glaciers and the weathering of time have obliterated all traces of the original meteorite. But it's estimated that a meteorite the size of a football stadium crashed into the Earth at 50 times the speed of sound. Even before Apollo 11's historic exploration of the Moon, NASA began examining the mechanics of how craters are formed. Researchers simulate meteorite impacts in miniature. A bed of fine sand represents the surface of the planet. This projectile gun will fire an aluminum bullet into the target at 5 miles per second. That's 18,000 miles per hour. By analyzing experiments like this, we can understand the dynamics of how craters are formed. A high-speed camera records the impact of the projectile. As the simulated meteorite passes through the air in the chamber, it begins to glow, brighter than the sun. On impact, this tremendous energy is released as heat, melting the projectile and the surrounding sand in a violent explosion. The shock wave is so powerful, it propels the sand outward at supersonic speed. From the point of impact, sand and molten material rise into the air. In the sand of the laboratory, all traces of the impact are easily smoothed away. But when the impact occurs in solid rock, the evidence can persist for millions of years. This is Wolf Creek Crater in Australia. It was formed from a relatively recent impact only about 100,000 years ago. The dramatically eroded Goss's Bluff crater of Western Australia shows how the weathering process eventually wore away most traces of our planet's primeval landscape. Sometimes, after a powerful impact pushes the floor of the crater down into the earth, it rebounds, raising a peak of rock at the center. At one of the Earth's largest known craters, Manicouagan Crater in Quebec, satellite photographs reveal a peak at the crater's center. Today, a lake surrounds the point of impact. Within the ring of water, a central peak rises above the trees on a large island. This is the central peak. It is 600 feet high and composed of solid rock that was forced up after the impact of a huge meteorite. At the foot of the peak, the shore also yields up some clues about the force of the collision. Dr. Dennis Roy of the University of Quebec's Geology Department has studied this crater and the effects of a meteorite strike. Near the central peak, rocks have been found that appear very similar to lava.
Actually, it was molten rock from the impact that made a pool in the crater and then solidified as if it were erupted from a volcano. So that rock is very, very similar to a volcanic rock, but its composition and its position in the structure indicates an origin from melting after the impact.
This same process has been observed on the moon. The central peak of the lunar crater Copernicus was also formed by a massive meteorite collision. The flat region around it was a depression filled with molten rock after the impact. This scenario has been played out on the Earth countless times, particularly in its early days. In that time, numerous planetesimals orbited the sun. The The primeval Earth must have been covered with craters. As the planet increased in size, it exerted a stronger pull of gravity. More meteorites were drawn to it at increasing speed. The great collisions caused intense heat that melted the surface, like the giant impact that created the Manicouagan crater. Gradually, over hundreds of millions of years, the face of the planet changed. The incessant bombardment began to melt the outer crust of the Earth. Deep below the surface, growing radioactivity heated the planet from within. A sea of molten rock covered much of the Earth, obliterating many of the earlier craters. Our planet, born in the cold depths of space, had become a fireball. How different the Earth is today. 4.5 billion years after the formation of our planet, we live in a mild environment, where the temperature hovers between the freezing and boiling points of water. Water can be found in one form or another almost anywhere on Earth, and it's the major component of virtually every form of life. But how did water emerge from a world of molten rock and falling meteorites? A clue may be found in the meteorites themselves. This is the Field Museum of Natural History in Chicago. It houses one of the world's most renowned collections of meteorites. Among them is the Murchison meteorite that fell in Australia in 1969. These fragments contain a sample of our primeval solar system, the hot gases and bits of dust that cooled and solidified. The Murchison meteorite caused a good deal of excitement because in it were discovered organic compounds from outside the Earth. It did not contain life itself, but rather amino acids, the building blocks of life. The meteorite also held within it another chemical compound that would change the face of the Earth. A simple experiment will reveal the secret. The sample is crushed and then heated to simulate what happens when a meteorite explodes on impact with a planet. The heat will release some of the gases trapped in the meteorite for billions of years. After about a minute, the glass vessel begins to cloud over as one of the meteorite's components begins to vaporize. A purified liquid is being extracted. This liquid is water, a surprising amount of which is released from even this small sample of a meteorite. The experiment helps focus attention on the role that early meteorites, the planetesimals, played in our planet's development from a fireball to a temperate world. Planetesimals continued to rain down on the developing planet, bringing water and other compounds, as they had for millions of years. Heated from above by the continual bombardment, the surface of the Earth became a sea of molten rock. Water locked within some of the meteorites vaporized on impact. Inside the Earth, radioactive energy generated intense heat, which emerged as volcanic activity. Through the tremendous heat, the great supply of water locked in the Earth from earlier planet-forming collisions was gradually forced to the surface. As the interior of the Earth became molten, the minerals began to separate. The denser ones, like iron, sank, while the lighter compounds, including water, came to the surface and evaporated. Vast amounts of water from within the planet joined with carbon dioxide and other gases to form thick clouds. As the clouds rose above the surface of this changing world, the force of gravity kept them from dissipating into space. This was the origin of the Earth's primeval atmosphere. Gradually, the number of planetesimals striking the Earth declined, and the surface began to cool. The temperature of the atmosphere began to cool as well, and the moisture-laden clouds began to descend. As the surface temperature gradually fell, a landmark event occurred. For the first time on Earth, it began to rain. Torrents of rain fell on the still hot surface of the new planet. It washed over the barren rocks and flowed down into the lowlands and broad plains. Eventually, the clouds broke, and the sun's rays spread across a new world, covered with broad blue oceans. number of meteorites hitting the Earth has declined drastically since the planet's infancy, but occasional impacts may still occur. The Barringer crater is one example of these latest collisions. This crater was blown out by a relatively small meteorite at that, only 100 feet in diameter. But what would happen if a truly massive meteorite crashed into the Earth? One controversial theory links meteorite impacts with evidence in the Earth's fossil record of a mass extinction. This global catastrophe occurred 65 million years ago, wiping out many species of land and marine animals, including the huge creatures which then ruled the Earth. They were called dinosaurs, the Greek name for terrible lizards. These giant reptiles flourished for over 145 million years. By comparison, our period of earthly dominance has been a fleeting instant. The dinosaurs may have been the most successful higher form of animal life ever to inhabit the Earth. Now, only a faint shadow of their glory remains. Today, dinosaur bones are found on every continent. These giants were widespread and able to survive in many climates and conditions. Characteristics of the once mighty dinosaurs are reflected today in reptiles like the land iguana, found on the remote Galapagos Islands. Marine iguanas frequent the waters around the Galapagos. They're an ancient species that trace back to the time of the dinosaurs, though they are not believed to be direct descendants of the terrible lizards. Modern reptiles have developed from these independent lines since the catastrophe which destroyed the dinosaurs. No one knows for sure whether or not a meteorite caused the dinosaurs to become extinct. In fact, the theory remains controversial, partly because we have found no traces on land of a crater large enough to have produced such a cataclysm. But there is some supporting evidence for both the theory of an enormous meteorite impact and the theory of mass extinction. On the coast of Denmark, these high cliffs at Stevens Klint contain a geologic record that spans the time of the dinosaur extinction, about 65 million years ago. It is here, in the layers of sediment, that strong evidence can be found for the theory of mass extinction. The thin dark layer between the white clay below and the pink clay above was laid down at the time of the dinosaur's death. The clay layer has been studied by Dr. Finn Serlich of the Geological Survey of Greenland.
It is a world-famous locality in geology because it is the type locality of the Cretaceous-Tertiary boundary. In the upper part of the cliff, from here and upwards, we have the lowest part of the Tertiary, and that is called the Danian, and it's named after Denmark. This is the so-called fish clay. It marks the boundary between the Cretaceous and the Tertiary periods. The fish clay is starting with this very dark brown or black layer. We had a very profound change in oceanographic conditions. Something clearly happened.
The clay above and below the dark layer holds many microscopic marine creatures, but the dark clay holds none at all. This layer, devoid of any evidence of life, is just one indication of the possible worldwide scope of the mass extinction. Here, on the Japanese island of Hokkaido, a search is underway for more evidence to support the global nature of this dark layer. A team of scientists from Tamagata University survey a rural hillside, looking for the distinctive band of clay. Here, halfway around the world from Denmark, they discover a layer similar to the one found at Stevens Clint. Above and below this dark band, the whitish remains of fossilized plankton are abundant. Within the dark clay itself, however, there is no sign of life. When this layer was deposited on the ocean floor, plankton were absent from the sea. Only an event of gigantic and catastrophic proportions could account for such an occurrence. But is this mass extinction linked to the impact of a huge meteorite? If a huge meteorite were to collide with the Earth, it would throw up enormous clouds of dust containing material from the meteorite itself. If an impact of this size devastated the dinosaurs' world, we should find traces of the meteorite in the lifeless layer of clay. At the University of California in Berkeley, Nobel laureate Luis Alvarez and his son Walter first proposed a theory in 1980 to link the mass extinction 65 million years ago with a giant meteorite impact. A team of scientists analyzed the various elements found within the clay. They collected 80 samples from all over the world. Their analysis of the dark clay revealed a significant fact. The clay contained unusually high amounts of iridium, an element normally found in very low levels at the surface of the Earth, but slightly more common in meteorites. Dr. Frank Asaro was one of the team that studied the clay samples at the University of California's Lawrence Laboratory.
When we first discovered the iridium, this was with the new detector, the big detector. We couldn't see it with the old ones. And we were very surprised because we didn't think we should see it. I didn't think we should see it. And it was a very large amount. And you couldn't explain that much iridium coming from the surface of the Earth, at least from what we knew at that time. So we said it had to come from outer space.
Iridium is found on the Earth as well, but most of it was carried toward the Earth's core during the planet's formation. According to Alvarez, one plausible explanation for its relative abundance in the dark bands of lifeless clay is the impact of a massive meteorite. The first samples of dark clay that revealed significant levels of iridium came from Gubbio, Italy. Iridium was later found in the dark band from the sea cliff of Stevens Clint in Denmark. One by one, similar samples of clay from all over Europe were found to contain iridium. Surface samples weren't the only ones to reveal the rare substance. It was also found in layers from the same time period formed on the bottom of the Atlantic Ocean and other sites around the globe. The slight but significant increase of iridium occurs in samples that date from 65 million years ago, at the time of the mass extinction. Scientists estimate that a meteorite containing iridium in the amounts discovered would have measured between 5 and 10 miles in diameter. But still the question remains, where did such a giant meteorite strike the Earth? A clue that may shed light on this question has been found at Caravaca, Spain. Here, in addition to the dark clay layer, there is also a narrow reddish band. Analysis has shown that the red vein contains materials that were probably formed by the massive melting of basalt rock on the ocean floor. This evidence, along with the absence of a huge crater on land, has led scientists like Dr. Jan Smit to speculate that the meteorite that may have killed the dinosaurs plunged into the ocean.
What we see here at this ancient sea bottom, within this reddish layer, are very tiny millimeter-sized droplets which originate by the force and the energy of the impact at the Cretaceous-Tertiary boundary. The force, the sheer energy of the impact melts a lot of surrounding rock, and this rock is thrown into the air, into outer space. It drops down on the seafloor where it's preserved as a solid layer.
In the dark layer of clay, scientists have also identified a type of soot produced by the burning of wood or fossil fuels. The amount of soot found in deposits from 65 million years ago is so large, it suggests many of the world's forests may have burned during this period. This is what might have happened if a giant meteorite crossed the Earth's orbit and collided with the planet at a speed of about 70,000 miles per hour. Let's suppose the impact occurred at a location where the ocean is over 1,000 feet deep. A meteorite 6 miles in diameter would hit bottom a fraction of a second after touching the ocean's surface. As the meteorite collided with the Earth, the impact would have caused an extraordinarily violent explosion. The energy released would be equivalent to 100 million megatons of TNT, far greater than the explosive power of the combined nuclear forces of the United States and the Soviet Union. The center of the explosion would reach temperatures 3 times hotter than the surface of the sun. The heat generated by the impact would start forest fires that would destroy plant and animal life over a vast area. These fires would only be the beginning of the far-reaching effects of a huge meteorite collision. The shattered seabed and fragments of meteorite would spread around the Earth in a tremendous cloud of debris. Along with the fine debris, water vapor would rise from the steaming ocean. The initial fiery holocaust would be followed by a long cloud-shrouded night, when sunlight reaching the Earth would be only 1/10 the intensity of moonlight. Under these conditions, air temperatures near the surface would drop rapidly to below freezing. In the cold and dark, photosynthesis would stop and green plants perish, breaking the first link of the delicate food chain. Many creatures, including the dinosaurs, would die of starvation. First, the plant eaters would face a dwindling food supply. Then the large meat eaters would not find enough prey to survive. The clouds of a long global winter would shroud the Earth. Gradually, the dust and water vapor from the meteorite impact would begin to settle out. The layer of lifeless clay would begin to sink to the ocean floor as the snow blanketed the ground. The temperature would gradually rise as more heat from the sun penetrated the thinning cloud. Snow would turn to rain, washing out even more of the remaining atmospheric dust. Only after several months would the clouds thin out enough to allow the sun to shine through on the Earth again. A falling meteorite causing worldwide catastrophe. This may have been what killed the dinosaurs that reigned supreme on Earth for 145 million years. But dinosaurs would not have been the only casualties of the impact. The consequences also would have been felt in the sea. The darkness that enshrouded the planet would have a similar devastating effect on life in the oceans. Phytoplankton, essentially the grass of the ocean, would be affected in the same way as land plants. The darkness would kill them. This would be a mortal blow to the many species that directly or indirectly depended on plankton for their own food. After plankton ceased to photosynthesize, the oxygen in the ocean would fall to lethally low levels in many areas, further spreading the devastation. Marine life would die in incredible numbers. With the break in this critical link of the ocean food chain, many species of animals and plants would die out. Was this mass extinction really caused by a giant meteorite? Did the dinosaurs die out in a dark world of ash and clouds? And is this global catastrophe only one in a recurring cycle of mass extinctions caused by meteorite collisions with the Earth? More discoveries about meteorites and mass extinctions have galvanized the scientific world. In 1983, two University of Chicago paleontologists concluded that mass extinctions have occurred on a 26 million year cycle. And another study of the Earth's best dated meteorite craters suggests that the collisions seem to occur in a similar cycle. Because of the lack of conclusive evidence, it is still unknown whether meteorite impacts actually caused these extinctions. But we do know one thing for certain. Meteorites do continue to bombard the Earth. There's a saying in Mexico that the Mexican Earth invites meteorites. The Mexico City Museum displays some of the largest meteorites that have fallen on that country. This one weighs 14 tons and is almost pure iron. It was once at the core of a much larger ancient planetesimal. This fragment of the iron core eventually fell to the Earth after two planetesimals collided in space. Even today, fragments of massive planetesimals continue to fall to Earth. On the night of February 8, 1969, a shower of meteorites fell on the small Mexican village of Allende.
Haga de cuenta que cuando venía el meteorito era de día, una iluminación como si fuera de día. Antes de caer vibraban las láminas, los techos de las casas antes de caer, y eso fue lo que nos hizo levantarnos esas vibraciones que había en las láminas. Lámina, el cine, no. Las ventanas metálicas, todo eso vibraban. Cuando esa iluminación se vio, ¿verdad? Se apagó la iluminación, entonces vimos el sonido que venía con ese tracateo que eran las piedras. Después lo vimos que eran las piedras. No sabíamos qué era ese tracateo tan fuerte. Fueron las piedras las que cayeron.
These are a few of the meteorites that fell from the sky that night, but they will not be the last ones to hit our planet. Today, astronomers are scanning the skies for the remnants of huge planetesimals called asteroids that still revolve around our sun. An astronomical observatory sits on top of Mount Palomar in California. One of its functions is to monitor asteroids and plot their orbits. For many years, research on the nature and movement of asteroids has continued under the watchful eyes of Dr. Eugene and Carol Shoemaker of the United States Geological Survey. Using a special camera and telescope with a wide visual field, they have identified 25 asteroids traveling on courses of particular interest. Each of these asteroids travels in an orbit that intersects the Earth's orbit. Although the probability is slight, if even one of the asteroids were to collide with the Earth as a meteorite, it would be disastrous. The film in the telescope's camera is exposed for many hours. Minute celestial bodies that are normally invisible to the naked eye can be seen as bright dots. Because an asteroid travels at an unusual speed and trajectory, it shows up as a short streak instead of a pinpoint of light. In March 1986, the Shoemakers discovered this asteroid. It's over 1 mile in diameter and made of iron. But the meteorite that may have killed the dinosaurs would have been 5 times this size. Is there a possibility that such a huge asteroid might strike again?
Yes, there very definitely is a chance that a 10-kilometer asteroid will collide with the Earth in the future. They have in the past. On average, they've hit about once every 50 million years on the long-term average. So the expectation is there's a better than 50% chance that in the next 50 million years, there will be another one of these that collide. We actually know of 2 asteroids right now. We've not discovered all of the Earth-crossing asteroids, but there are 2 of them that we know that are about that size, each of which could hit the Earth. And in fact, there are even bigger asteroids. There's an asteroid called Eros, which has about a 20% chance of hitting the Earth in the next several hundred million years. And this asteroid is about 20 kilometers in average diameter, so it would produce an even bigger effect.
A Wyoming family took home movies of this meteor, whose weight is estimated at 1,000 tons. Fortunately, the meteor didn't collide with the Earth. It skimmed through the high atmosphere, leaving a white trail. If it had struck the Earth, the disaster would have rivaled a nuclear explosion. Today, a large meteorite collision with the Earth would be a major disaster, to say the least. But meteorites have played an important role in the development of our temperate world. 4.5 billion years ago, the combining of countless planetesimals formed the physical planet that we call Earth. They carried the building blocks of our planet. As their frequency declined, the Earth changed dramatically, and eventually great oceans of water covered the surface. Throughout the Earth's long history, periodic meteorite collisions may have dramatically affected the development of life on our planet, causing the extinction of some species and allowing others to succeed. Will a great meteorite change the Earth in our lifetime? Probably not. According to one theory, the next visit of huge meteorites isn't expected for another 15 million years. But no one knows for sure what may cross our path. From the very formation of our miracle planet, we are linked with the meteorites.
Stay tuned as Jacques Cousteau and the crew of the Calypso rediscover the Marquesas Islands following program previews. And be sure to join us when nature travels to the Pacific Northwest to explore the Emerald Sea. That's Thursday at 8 p.m. here on TV 12.
Funding for the Miracle Planet was provided by Bull Worldwide Information Systems, unleashing the power of computers for customers on 5 continents.
And by Amoco, fueling the American dream for the year 2000 and beyond. And by viewers like you. The Miracle Planet is available as an educational package. To order, call 1-800-843-0048.
The new Yankee Workshop projects are now available on home video. To order your copy of the project you have just seen, you may call 1-800-843-0048. Please have your credit card ready. Each home video includes a measured drawing with all the dimensions you will need to build your project. The price for this home video is $24.95 plus shipping and handling.
Local broadcast of the new Yankee Workshop is made possible in part by Force Machinery, distributors of Delta International Woodworking Machinery, and Porter Cable Portable Electric Tools. Porter Cable Electric Tools are available at Force Machinery, 914 East Main Street in Norristown.
Good evening. I'm Sue Serio with your Delaware Valley Weather Report. Weather word for tomorrow is rejuvenate. The sunshine returns on Tuesday. A nice day for January, highs in the upper 40s. For the days ahead, a 40% chance of showers on Wednesday, then clear skies return on Thursday and Friday. And we expect highs around 50 all 3 days. I'm Sue Serio bringing you a pretty nice Tuesday. Stay tuned for the Miracle Planet coming up next.
TV 12 News is made possible in part by Mellon Bank, Delaware, offering a full range of financial services, including home improvement loans and home equity credit lines. Mellon Bank, Delaware, proud to serve the banking needs of the people of the First State.
Feel the heat within, next in stereo on the Miracle Planet.
Hello there, Harvey here, as in Harvey in the Morning from Magic 103. All of us at WMGK are proud to join you in supporting the fine programs here on TV 12. So settle back and enjoy, because here comes another one. See ya.
For generations, people have wondered about the Earth. How can mountains grow and living creatures be turned to stone? How can a planet covered by cool oceans be hot enough inside to shine like a star? Join us in a search for the heat within the Earth. It has transformed the surface over billions of years. Even now, this heat is bringing into being a very different world of tomorrow. The heat within, this time on the Miracle Planet.
Funding for the Miracle Planet was provided by Bull Worldwide Information Systems, unleashing the power of computers for customers on 5 continents.
And by Amoco, fueling the American dream for the year 2000 and beyond. And by viewers like you.
Hello, I'm Bill Curtis for the Miracle Planet. Every year, thousands of people come to Yellowstone National Park to see the geysers, the hot springs, and the mineral terraces. But as dramatic as Old Faithful and the Minerva Terrace may be, even more amazing is the power that drives them. Beneath the Earth's crust, there is a sea of molten rock, which heats groundwater and forces it to the surface. This water is turned to steam and mixed with minerals to produce the marvels that have made Yellowstone famous. Although the Earth's internal heat is not always so dramatically displayed, it is still apparent all over the world, from the highest mountains to the deepest oceans. But what is the Earth like deep beneath the surface? We can't really travel to the core as Jules Verne imagined in Journey to the Center of the Earth. But there is one place where we get a sense of the Earth's interior heat. This is the Western Deep Levels Mine in South Africa's Witwatersrand. Less than 50 miles from Johannesburg, this mine tunnels as far beneath the Earth's surface as many mountains stand above it. The lure of gold is the driving force in this venture into the Earth's interior. A century ago, gold was mined near the surface. But today in South Africa, it is mainly found in ultra-deep deposits. To reach the bottom of the Western Deep Levels Mine, elevators plunge downward at a speed of 25 miles an hour. At the end of their journey, the miners arrive 11,738 feet below the surface. This literally is the deepest point in the world to which humans have ventured. The greatest challenge to mining at this depth is not the lack of air or threat of cave-ins. It's the heat. Drilling into the rock reveals why. Just beneath the surface, the temperature is 52 degrees Celsius, hot enough to burn the naked hand. Yet Western Deep Levels Mine is a mere scratch in the uppermost layer of the Earth. The labyrinthine tunnels of the gold mine are insignificant when compared to the vast interior of the planet. Beneath the Earth's crust are the mantle, the liquid outer core, and at the center of the planet, an intensely hot and dense solid core. Deep within, the Earth reaches a hellish temperature of 11,000 degrees Fahrenheit. Beneath the surface of our mild, temperate world is an inferno. A mere 30 miles of hard rock separates the surface from the hot interior. How did the Earth develop in this way? To understand, we must return to the dawn of planetary time, billions of years ago. In that primordial era, planetesimals rained down on the Earth. the energy released by their impacts eventually turned the surface into a red-hot sea of molten rock. Deep within the Earth, a tremendous amount of heat was generated by naturally occurring radioactivity. This nuclear furnace, fueled by radioactive decay, turned the inside of our world into a molten mass. More than 4 billion years later, the interior of the Earth continues to generate enormous heat, which rises toward the surface and in some places breaks through the thin, cool crust. Iceland is one such place. Despite its name, Iceland is the world's largest volcanic island. Much of the land is covered by glaciers, but the snow and ice blanket the true origins of the landscape. Beneath the ice, the land has been formed by lava from repeated volcanic eruptions since prehistoric times. This volcanic heritage is particularly evident at Lakagigar crater, actually a row of craters. In 1783, Lakagigar was the scene of an immense eruption which killed half of Iceland's livestock and 1/5 the human population. Iceland is still volcanically active, with an average of 1 major eruption every 5 years. Unusual formations on the landscape testify to this ongoing process. When lava cools, it sometimes cracks into hexagonal columns as much as 65 feet tall. Iceland is an extraordinary island where fire and ice exist together. Underground hot springs melt glacier ice, creating streams that in turn become rivers. The rivers have their source in caves beneath the glaciers. Here the cave extends for over a mile, and the water is pleasantly warm. In fact, even though there are tons of ice overhead, the hot water makes this a comfortable place for bathing. The heat beneath the surface finds release in a variety of ways. In recent years, the center of activity has moved from Lakagigar to the Krafla area. Here, Dr. Gudmundur Sigvaldason observed the beginning of an eruption on September 4th, 1984.
There had been 2.5 years without any eruption in this area, and we knew that the magma reservoir, the magma container down at 2.5 kilometers depth, was under very high pressure. Then suddenly in the evening at about 8:30 in the night, then we heard that there had been a sudden pressure release. So we knew that the magma was on its way to the surface.
Within minutes, the night was in flame, and Krafla transformed beyond recognition. In the beginning, there were 2 distinct curtains of fire, but they joined as the eruption grew. Soon, lava was erupting 500 feet in the air and spreading out over a 5.5-mile front. The searing heat of the Krafla eruption churned the cold night air into violent tempests. The surface lava was swept up into burning cyclones. Hellish vistas like this, first witnessed by 9th century Viking explorers, must have evoked terrifying visions of doomsday. Actually, this is a picture of birth as much as destruction. Flows like this, spreading again and again over millions of years, are what formed Iceland. On layer after layer of lava, this island has risen above the surface of the ocean. The 1984 eruption at Krafla lasted a week, leaving behind a row of smoking craters. The eruption occurred along a fissure, where the earth cracked open in a long line. Fissures are found in many parts of the world where volcanic activity occurs, but nowhere on land are fissures more common than on Iceland. This is the largest Icelandic fissure, called Thingvellir. It opened up a gash 25 feet wide and cut the rocky landscape to a depth of more than 50 feet. Thingvellir is unmistakable evidence of the heat within the earth and the enormous power unleashed when that energy escapes. The major volcanoes of Iceland rise in a line extending from the northeast to the southwest. The island's fissures run in the same direction and continue off the land into the sea. In 1974, far south of Iceland near the Azores, French and American scientists began exploring the floor of the Atlantic Ocean. At a depth of 10,000 feet, they found the ocean floor to be much different than they expected. It was littered with strange, round rocks. Similar rock formations had been previously discovered off Hawaii when lava flowing from a volcano poured into the ocean. It was named pillow lava. The characteristic pillow shape results from the sudden chilling of the lava when it contacts seawater. This pillow lava was found at the bottom of the Atlantic. It proved that this portion of the ocean floor had been volcanically active. No sediment had yet settled on the rocks, indicating that the activity was recent. Soon, evidence of undersea volcanism was discovered on the other side of the world. In 1977, the American research submarine Alvin was involved in another historic ocean floor exploration. This time, the site was the Eastern Pacific, where at a depth of 8,500 feet, researchers came upon something quite unexpected. In the faint illumination of their lights, the submarine crew saw a forest of eerie chimney-like structures, which seemed to be emitting dark clouds of smoke. Although they are called black smokers, the billowing discharges actually proved to be superheated water, colored by particles of metallic minerals. The chimneys themselves are made of solid mineral deposits that precipitated out of the water, primarily iron, zinc sulfide, copper sulfide, and silver. Another surprise was the incredible abundance of life in and around the black smokers. Here in what to us are almost unimaginably hostile conditions, anaerobic bacteria thrive and provide the foundation for a rich food chain. Further north in the Pacific, off the coast of British Columbia, Canadian researchers found new types of smokers. They discovered vents where the discharge was white and even colorless. Like black smokers, they were intensely hot. In this case, 294 degrees Celsius, hot enough to melt lead. Evidence from around the globe indicates that certain regions of the ocean floor are volcanically very active. Survey work in the Eastern Pacific, off the coast of Mexico, provided data to construct a model of the ocean floor and a high mountain range running north to south. Volcanic activity in the ocean is centered on this undersea range and the deep valley that runs along the crest. The valley walls are shaped like steps and marked with volcanic fissures. The ocean floor is studded with smokers, indicating continual geothermal activity. Increasingly, evidence points to the conclusion that there is more volcanic activity on the seafloor than on dry land. In fact, underwater volcanism has been observed along undersea ridges in the Atlantic Ocean, in the Red Sea off the coast of Africa, and all along the Pacific coast of the Americas. The heat within our planet is constantly flowing toward the surface. This is what forces up the ocean floor and causes fissures in the surface. Through these mountains at the bottom of the ocean, the heat within the earth is continually released. A reservoir of molten magma rises close to the surface beneath the mid-oceanic ridge. The magma heats the rock on either side and is responsible for the new lava that is constantly being erupted. The seafloor is dissipating heat as it spreads away on each side of the mid-Atlantic ridge at less than an inch per year. But some points along the mid-Pacific ridge are spreading 9 times that rate. Undersea mountain ranges stretch almost continually from off the coast of Mexico across first the Pacific and then the Indian Ocean. The ridge continues around the Cape of Good Hope and northward through the Atlantic Ocean. This 45,000-mile-long volcanic range serves as an immense natural radiator, continually releasing heat from within our planet. The Earth most resembles the other 3 inner worlds, both in terms of its rocky composition and its history of volcanism. Mercury, Venus, Earth, and Mars, they were all formed in a similar manner. But the cooling process in each of these rocky worlds has taken a different course. Mars is the 4th planet from the Sun. Its orbit is just outside that of Earth's, but its surface is dramatically different from our blue world. The red planet is covered with craters, much like the Moon. A striking feature is the huge volcano, Olympus Mons. More than 15 miles tall, this Martian colossus is the largest known volcano in the solar system. It's evident that Mars was once volcanically very active, but those eruptions ended more than 100 million years ago. On Mercury, the planet closest to the Sun, there are signs of surface movement. Amid the craters are immense cracks that were formed when the planet shrank during its relatively quick cooling period. These sheer cliffs are as much as 2 miles high and 250 miles long, and point to a time shortly after Mercury's formation when all volcanic activity stopped. Earth is much larger than Mars or Mercury and is taking much longer to cool. Its internal heat continues to vent and reshape the surface of the planet through undersea volcanic activity and on the surface as well. Djibouti is a small country in Africa, part of the highly volcanic Afar Triangle. The daytime temperature can reach 122 degrees as winds blow clouds of dust across the bleak terrain. At first glance, this desert wasteland seems dry and geologically stable. But there is evidence that the land is in the process of being reshaped. Amid the mirages that dance across the Afar Desert lie some truly unusual rock formations. These towers, which reach as high as 200 feet, are called travertines. In the midst of the blazing desert, they periodically give off steam and hot water. Many travertines stand in neat rows following the line of underground fissures. It's no coincidence that they resemble the chimney-like smokers found on the sea floor. These inland travertines were formed by billowing smokers on the bottom of an ancient lake. They grew tall from the lake's rich mineral supply of calcium carbonate. Even today, underground water boils up into pools on the dry lake bed. It's an indication that this land is still in the process of change, fueled from the escaping heat within our planet. Because the travertines are located over a major rift or fault line in the Earth's crust, earthquakes are frequent. The epicenters of these quakes stretch in a line from the northwest to the southeast. This whole area is sinking from the seismic activity, creating a deep terraced valley. It's the northern end of Africa's Great Rift Valley that stretches almost 4,000 miles from the Red Sea in the north to Mozambique in the south. "4 million years ago, the land cracked open here, creating well-watered valleys where wildlife flourished. At Tanzania's Lake Natron, in the heart of the Great Rift Valley, the water is blood red. The unusual color is due to soda-rich water, forced to the surface by the hot magma below. The alkaline water kills everything but red-colored bacteria, and the sun creates patterns on the surface that change constantly. The Great Rift Valley is an extension on land of the undersea ridges that circle the globe. And like those fault lines, the valley is growing deeper as the land moves away on both sides, split apart by the heat within the earth. It's the result of what might be called the blanket effect. The landmass of a large continent holds heat better than the thinner ocean crust. The intense heat accumulates beneath the continent, trying to escape. As the heat builds, the continent rises and finally splits. Fissures appear on the surface, then a long rift valley. Eventually, the oceans fill the valley as it continues to spread. In this way, the continents have been reshaped and have drifted across the face of the globe, powered by the energy escaping from within the Earth. The familiar face of the globe as we know it today, with huge oceans separating the Americas from Eurasia, was once completely different. 250 million years ago, there was one huge continent called Pangaea. Driven by the heat within, the supercontinent split apart. Where once there was land, rifts opened and filled with water. The land continued to spread away on each side, and in time, the modern continents took shape. This process is happening today in the Great Rift Valley. Here, the land is splitting apart. Every year, the valley gets wider. The progress is slow, less than an inch a year, but it is relentless. The African continent is slowly breaking up. As the land gradually sinks and splits, more lakes will form, and eventually the sea will fill the long valley. This is how a continent begins to divide. 50 million years from now, the global map may show an African sea. As continents pull apart on one side of the globe, they must inevitably come together on the other. In fact, continental and oceanic plates are in collision all over the world, driven by the heat within our planet. Often mountain ranges are pushed up where plates come together. The Andes of South America and the European Alps were born in this way, as was the tallest range on Earth, the Himalayan mountains. The lofty peaks of the Himalayas reach through the clouds to the sky. The immense mountain range extends for more than 2,000 miles from east to west and covers an area the size of East and West Germany combined. The word Himalayas comes from Sanskrit and means abode of snow. This is a frozen world above the tree line. 14 peaks tower over 26,000 feet high. Among the highest are Everest, Annapurna, and K2. The Himalayan mountains touch the roof of the world. At one time, however, the rocks that make up the Himalayas were at the bottom of the sea. There is fossil evidence high in the mountains of sea creatures, like this bivalve. These marine organisms inhabited the warm seas of ancient times. Embedded in the brown stratum are the grayish remains of many crescent-shaped fossils. Their numbers testify to the richness of life in the ancient sea. In addition to bivalves, there are many other fossils of ancient sea life. Here, preserved in stone, is a crinoid sea lily. Although very small, it's an ancient relative of the sea urchin and starfish. Even more fossilized sea life appears under magnification. The large round-shaped object on the left is another sea lily, while the smaller object on the right is an ancestor of modern coral. Even smaller is the foraminifer, a primitive diamond-shaped creature that's a species of plankton. This is the cross-section of a tiny fossil snail that once inhabited the tropical seas of our planet. Elsewhere in the Himalayas, there is even more remarkable evidence of the marine origin of these mountains. The scallop pattern on this hillside is the fossilized impression of waves on an ancient seabed. It's similar to the ripple pattern found today on the bottom of shallow seas. In many ways, however, the world was a much different place when ocean waves left these impressions. Between 220 and 70 million years ago, during the Mesozoic era, the oceans of the world were inhabited by many species that are now extinct. Among the denizens of these ancient seas were tube-shaped belemnites. Ammonites were also common. Their name comes from the ancient Egyptian sun god Ammon, who is believed to have a spiral sheep's horn on his head. They're a species of cuttlefish that first appeared on Earth 400 million years ago. Today, evidence of these ancient sea creatures can even be found among the highest Himalayan peaks. From this fossilized belemnite, only the tube-shaped central portion remains. The name of this squid-like creature comes from the Greek word belmnon, meaning spear-shaped. Here, too, are ammonites, locked in stone. The fossilized impression is all that remains of a creature that lived before the Himalayas were born. Ammonites thrived during the time of the dinosaurs, but became extinct about 65 million years ago. Now the remains of these and other ancient sea creatures are found near the top of the world's highest mountains. How did this happen? It's a journey that began when this region and the rest of the world looked much different than today. This is a computer-generated view of the Earth. The 7 seas and 6 continents form a familiar picture. But this was not always the case. The continents were in different locations when the Earth was younger. By projecting back in time, the course of these wandering continents becomes clear. India, shown here in yellow, was once located in the southern hemisphere. Africa was separated from Eurasia by a broad, shallow sea. Even before this, all the continents were joined together. North America was connected with Europe, South America with Africa. On the opposite side of the globe, a vast ocean spread from pole to pole. This is what our Earth must have looked like 200 million years ago. But the heat within our planet was already beginning to drive the continents apart. It forced India northward. For 100 million years, this African island drifted more than 4,000 miles toward Asia, at a rate of 15 to 30 feet per century. Slowly, it crossed a vast, shallow sea, teeming with life. As the two land masses drew close, seafloor sediment between them was compressed and folded. A chain of small islands began to appear in the narrowing remnant of the shallow sea. Once, this island archipelago must have been a marvelously lush place. Then, 45 million years ago, it vanished forever when India slowly crashed into Asia in one of history's truly earth-shaking collisions. Barely slowed by the initial contact, India continued to slide under the larger landmass. Upthrusting began to occur all along the line of collision, pushing up the seabed that contained the remains of marine creatures. Higher and higher the mountains climbed, until they formed the tallest range on Earth. The process of continental drift that formed Mount Everest and the Himalayan peaks also created many other Eurasian mountain ranges. An interconnected chain of mountains runs from the Himalayas through the Hindu Kush and the Caucasus Range. From the Carpathians and the Alps to the Pyrenees and the Atlas Mountains. All these ranges were born at roughly the same time, and all were formed in a similar manner. The rocks that make up the fabled 38 summits of the Alps, for instance, show many signs of undersea origin. Pillow lava, which originally erupted underwater, can be found here at 6,500 feet above sea level. Here, too, are many limestone cliffs built up from the fossilized remains of ancient sea creatures. Even though 3,000 miles separate the Alps from the Himalayas, thousands of fossil ammonites, common to both, crowd this French cliff face. When these creatures died, their shells were deposited on the bottom of the ocean. Later, the seafloor was tipped vertically and forced several thousand feet into the air by the enormous force of colliding continents. As the African continent drove north toward Europe, the shallow seabed between them was compressed and racked into an incredible array of folds. There are places throughout the Alps where there is evidence of the powerful forces that twisted the rock, turned it upside down, and raised it toward the sky. The enormous energy within our planet gradually moves continents and pushes up great mountain ranges. This same force is also responsible for purifying many minerals and bringing them within our reach. One mineral that has long been important to humanity is copper. From the first metal tools of the Bronze Age to the electric wiring in modern homes, copper has helped shape our civilization. And yet, without a unique natural process fueled by the internal heat of our planet, copper would not have been available to lift us out of the Stone Age. The island of Cyprus in the Mediterranean Sea is rich in copper. In some places, the mineral was found right on the surface. This easy access to the copper ore was particularly important to its early discovery and use. Over 3,000 years ago, miners first brought this precious metal to an eagerly awaiting world. Copper was one of the first metals known to mankind, and the first used to form tools, utensils, armor, and art. Copper was used by ancient Mediterranean peoples to express their dreams and fears. Achilles wore a helmet made of bronze, an alloy of copper and tin, as did his opponents on the fields of Troy. During the Bronze Age, Cyprus prospered as the principal source of the metal for the artistry of Greece and Persia. Early Mediterranean civilizations flourished because of this copper wealth. The English word for copper is even derived from the ancient Greek name for Cyprus, Kuprios. The island of Cyprus and its concentration of copper originated on the floor of the ancient Mediterranean Sea. Here, along an undersea fissure, heat from the Earth concentrated the copper through an extraordinary process. Below the seabed, water seeped down toward a huge pool of magma, straining to escape. As the cool seawater met the molten magma, it was heated. The superheated water percolated through the rocky crust, leaching out small amounts of copper compounds. Some of the mineral was then deposited in the surrounding seabed as the water forced its way upward. Finally, the superheated water appeared as white and black smokers. Year after year, the concentration of copper continued to build around the smoking chimneys, fired by the heat of the Earth itself. Over many millions of years, the volcanic activity in this fissure forced the seafloor apart, and the rich deposits of ore were carried away. The copper deposits were brought to the surface when the copper-rich seafloor collided with the European continental plate, forming the island of Cyprus. But this is only one of the ways that copper and other minerals have been naturally refined by the internal heat of our planet. The majority of the copper produced today comes from Chile, in the Andes Mountains. Layers of light and dark rock contain a wealth of fossilized sea creatures. Like the Himalayas and the Alps, this area was also once at the bottom of the sea and then pushed up. The Andes rise along the western coast of the South American continent. Spanning 5,000 miles from one end of South America to the other, the Andes is the world's longest mountain range. Its highest peaks soar above 20,000 feet and are still growing. The Andes hold a wealth of minerals: gold, silver, tin, and copper. Almost all of South America's copper mines can be found in the Andes because the same force that pushed up these mountains also formed the rich mineral deposits. The mineral resources found in the Andes are the result of volcanic activity. The heat rising close to the surface is evident throughout the Andes today. This steaming peak is nearly 4 miles above sea level. On the high plateaus between the peaks, mineral water bubbles up from deep underground. Even at such high altitude, the heat within the Earth rises very close to the surface. Water from melting snow seeps into the rocks. There it is heated by the magma and bubbles back to the surface. Water is the key to concentrating the mineral wealth of the Andes. "40 million years ago, there was extensive volcanic activity in the mountains of the Andes. During this ancient time, there were many minerals, including copper, hidden below the surface. But these elements were scattered in very low concentrations. If the copper had remained in such a scattered form, it could not have been mined. But through a special process, the volcanic magma transformed them. Around the perimeter of the underground pool, the magma began to cool, and minerals held in solution began to crystallize. The superheated water contained in the magma rose up. The copper compounds, dissolved in the water, rose as well. The heated water gathered on the roof of the magma pool. Pressure built and cracked the surrounding bedrock. Water seeped through the fissures, taking the copper with it. As the water moved up through the earth, it cooled, and copper was deposited along the way. The result, veins of copper ore. Copper pyrite is formed by this process of water interacting with hot magma. The concentrating action of water and cooling magma has resulted in a vast deposit of copper ore in the Andes. This is the Chuquicamata mine in Chile, the world's largest copper mine. The pit is 4 miles long and 440 feet deep. But despite its great depth, this excavation only scratches the surface of the copper ore concentrated by the heat within the earth. The volcanic activity that moves the continents and forces up the mountains has naturally refined copper, gold, and other minerals. Without this first natural step, copper would be too scattered to mine effectively. But mining copper ore is only the first step in the process. The copper is still not concentrated enough for us to use. Changing solid rock into liquid may be natural enough below the thin crust of our planet, but on the surface, it is not a simple task. Today, we purify copper in huge mechanized smelters. Copper ore, which may be only 1 or 2% copper, is melted in horizontal furnaces and refined into ingots of nearly pure red metal. Knowledge of how to smelt copper was one of the crucial discoveries that launched humanity on the road to modern civilization. We've come a long way from the first implements of the Bronze Age, thanks to our ingenuity and the internal heat of the Earth. On the surface, the Earth is a temperate, hospitable world, with oceans of liquid water and a cool, oxygen-rich atmosphere. But not too far beneath the crust, our planet is very different. Inside the Earth, the temperature is hot enough to melt the hardest rock. Over billions of years, this internal heat has shaped the surface of our planet. It made the mountains and oceans, moved great continents, and concentrated minerals like copper and gold. It is responsible for hot springs under Iceland's glaciers and blood-red lakes in the heart of Africa. Strange, sinking valleys and the tallest mountains. Even now, the heat from within continues to forge a new world from the material of the old.
Coming up next, it's the story of Hitler's reign of terror, the rise and fall of the Third Reich. Next, here on TV 12.
Funding for the Miracle Planet was provided by Bull Worldwide Information Systems, unleashing the power of computers for customers on 5 continents.
And by Amoco, fueling the American dream for the year 2000 and beyond. And by viewers like you. The Miracle Planet is available as an educational package. To order, call 1-800-843-0048.
If you would like a measured drawing of the Adirondack chair, please send $5 to Adirondack Chair, care of the New Yankee Workshop, Box E, Bedford, Mass. 01730.
This is PBS.
Local broadcast of the New Yankee Workshop is made possible in part by Force Machinery, distributors of Delta International Woodworking Machinery, and Porter Cable Portable Electric Tools. Porter Cable Electric Tools are available at Force Machinery, 914 East Main Street in Norristown.
Good evening. I'm Sue Serio with your Delaware Valley Weather Report. Weather for tomorrow is amusing. After a rainy Monday, Tuesday's weather is sure to bring a smile. We're expecting mostly sunny skies and a high in the lower 50s. For the days ahead, the rest of the week doesn't look so bad, except for a bit of rain on Thursday. By the end of the week, though, we should cool back into the 40s. I'm Sue Serio bringing you a great Tuesday. Stay tuned for the Miracle Planet coming up next.
As part of its commitment to the community, Hercules and its employees are proud to help bring you TV 12's news programming.
Hello there, Harvey here, as in Harvey in the Morning from Magic 103. All of us at WMGK are proud to join you in supporting the fine programs here on TV 12. So settle back and enjoy, because here comes another one. See ya.
For generations, people have wondered about the Earth. How has this ancient cave-riddled landscape changed the very air we breathe? Are these stepping stones on a sunny beach, or living organisms that date back to the dawn of time? What role will these modern sea creatures play in shaping the future of the Earth? Join us in a search for ancient forms of life that have transformed our oceans and our atmosphere. Today, their descendants are still helping to maintain the Earth's temperate equilibrium. Life from the sea, this time on the Miracle Planet.
Funding for the Miracle Planet was provided by Bull Worldwide Information Systems, unleashing the power of computers for customers on 5 continents.
And by Amoco, fueling the American dream for the year 2000 and beyond. And by viewers like you.
Here at the Pacific Coast, it's easy to feel the vastness of the oceans that cover more than 70% of the planet's surface. Hello, I'm Bill Curtis for the Miracle Planet. We know of no other place in the universe where large seas of liquid water exist where mild temperatures prevail and life abounds. How did the Earth develop into a temperate, life-sustaining world? Living creatures have played a crucial role in the process by altering the balance of important elements like oxygen and carbon dioxide. In fact, life itself has helped create the conditions for its own success. It all began out there in the ocean. Traces of the earliest life on Earth can be found today in Shark Bay on the west coast of Australia. Far inside the shallow bay is a lagoon known as Hamlin Pool. This placid shoreline is studded with strange formations. Called stromatolites after the Greek translation for bed of rocks, they are actually built by colonies of microscopic organisms. These stromatolites are the rocky homes of those creatures. The organisms need sunlight to live and spread out in the crystal clear shallows of the Australian coast. Because of its remote, salty nature, Hamlin Pool provides a nearly ideal situation for these microscopic creatures. In this shallow haven, they are largely free of predators. Here they flourish, the descendants of ancient organisms, building up their pedestals of rock. Hamlin Pool provides a glimpse of what the shallow seas of our world might have looked like more than 3 billion years ago. In these waters, the ancient process of forming stromatolites is still going on today. The surface of the rock appears soft and slimy. The bubbles are oxygen given off by tiny creatures. The yellow-green tint is chlorophyll, essential for the most common form of photosynthesis in plants. The surface of these stromatolites is actually covered by one of the Earth's most primitive forms of life. Magnified many times, this is blue-green algae, or cyanobacteria, as they are called today. Like their more highly developed relatives, the green plants, cyanobacteria produce oxygen as a byproduct of photosynthesis. Further magnification of the bacteria reveals their long, thin cell covered by a sheath. Because it's rather sticky, the sheath collects grains of sand and other minute bits of debris. In stromatolite construction, the stickiness is the mortar and the sand is the masonry. On the seashore, the natural habitat of cyanobacteria, the waves are constantly stirring up the sand. This incessant action of wave and wind provides a virtually endless store of raw materials for the stromatolite builders. The stromatolites are formed bit by bit over an extended period. Some are the work of hundreds of thousands of years. Every day when the sun beats down on the cyanobacteria, the cycle of growth continues. Using photosynthesis, they grow by converting sunlight and carbon dioxide into food and oxygen. The wave action of the ocean deposits fine grains of sand on the surface of the stromatolites. At night, the cyanobacteria secrete calcium carbonate, which cements the mud and sand. Then, in the light of a new day, photosynthesis begins again, and the cyanobacteria continue the ancient cycle. The rate of growth is slow, a tiny fraction of an inch per year. But repeated over countless days and nights, this process can create large, stony colonies. Over an extended period of time, it can produce huge rock formations. The cyanobacteria that built these rocky stromatolites are a very simple and ancient life form. They appeared on Earth billions of years ago and have remained largely unchanged in nature and habit. Yet, despite their antiquity, they are by no means the oldest form of life on Earth. In recent years, scientists have found evidence of even older organisms that make these stromatolites look complex by comparison. In the search for traces of ancient life, an exciting discovery was made here, near a blazing spot in the desert that the Australians ironically call North Pole. In 1976, in what appears to be very ordinary rock, scientists discovered the oldest known fossil creatures. They dated the sample at 3.5 billion years old. One of the paleontologists who discovered the North Pole fossil is Dr. Malcolm Walter of Australia's Bureau of Mineral Resources. This is what one form of life on Earth looked like 3.5 billion years ago. These two linked spheres are believed to be a primitive bacteria-like creature immediately after cell division. Is this the first life on Earth? Based on his examination of the fossil bacteria found at North Pole, Dr. Walter does not think so.
The first thing they tell us is that even 3.5 billion years ago, life was quite complex, even though the organisms we consider were only bacteria. They were quite complicated sorts of bacteria, and many different types of bacteria as well. So we can suggest that the origin of life must have been some long time before 3.5 billion years ago. That was a surprise to discover how complex these organisms were at that time.
The discovery of a complex bacteria-like creature dating back 3.5 billion years was in itself a major find. But there was another discovery at North Pole, Australia. These stromatolites were discovered in the same strata as the oldest fossil. The original shapes have been distorted over time, but here is proof that stromatolites like the ones in Hamlin Pool were being formed at the same time as the earliest known life on Earth. Ancient colonies of cyanobacteria, the organisms that built these rocky forms, were photosynthesizing, producing oxygen, and changing the environment of the world more than 3 billion years ago. The dramatic discoveries at North Pole, Australia, have underscored the great antiquity of life. Since the oldest known life forms seem relatively complex, it's likely that even more primitive forms preceded them. Life may be far older than the oldest fossil records. Little evidence remains from the early years of Earth's development. Scientific theories disagree about the exact nature of our primordial planet, but one thing is certain. The world was very different then from what it is today. The newborn Earth was a dim world where the sun shone much less intensely than now. Meteorites plunged continually through the primeval atmosphere. The meteorite impacts heated the planet's surface, causing the release of water vapor and other gases. During this period, the same world-forming process was also taking place on Venus. But on Venus, the clouds of carbon dioxide and water vapor built up into a thick layer, trapping tremendous heat close to the planet's surface. Because Earth was farther from the sun, it continued to cool. The atmosphere surrounding the Earth reached a crucial point. Instead of growing thicker, the clouds would release their store of moisture. For the first time on Earth, rain began to fall and continued to fall as our world slowly cooled. For millions of years, the water poured down, covering the Earth with great oceans. Much of the carbon dioxide in the atmosphere dissolved in the oceans, preparing the way for life to develop. To find out what life may have been like at the dawn of time, we must return to the sea again. During the 1970s and 80s, scientists in research submarines were diving off the Pacific coast of North America, from Canada to Mexico, to depths of nearly 9,000 feet. On the ocean floor, they discovered an unexpected form of geothermal activity. Called black smokers, these vents actually discharge superheated water, highly acidic and laden with dissolved minerals. Even more surprising than the smokers themselves was the discovery that these areas are tremendously rich in bacteria. These primitive creatures survive without oxygen or light from the sun. Instead, they derive their energy from the mineral-rich water. The conditions here seem incredibly hostile to life as we know it. Yet the earliest forms of life on our planet may have flourished in such an environment. On land, too, we can still find the conditions that may have supported early life. The Yellowstone National Park is the site of some of the world's most distinctive geothermal displays. Originally created by a series of volcanic eruptions, the area is still active. Today, the 2-million-acre national park contains more than 200 geysers and 10,000 hot springs. One of the gems of Yellowstone is the Grand Prismatic Spring. Almost 100 yards in diameter, its brilliant color is the result of minerals dissolved in the water. Yellowstone's geysers reach as high as 300 feet. The best-known geyser is Old Faithful, which erupts once every hour. In some locations, hot water carries dissolved minerals up to the surface of the earth. Calcium carbonate and other compounds precipitate out. The result is the formation of natural terraces. This is Minerva Terrace. At Yellowstone, a primordial quality permeates even the streams and waterways. Hot water pools are the home of strange growths, reminiscent of a more ancient time. Paint pots and mud volcanoes bubble at almost 200 degrees. The boiling temperature is only one of the inhospitable aspects of this volcanic water. It's also highly acidic. Splash a little on your clothing and the fabric would char immediately. Almost 200 degrees Fahrenheit, pH factor 1, and no free oxygen. Conditions like these were common on our primordial Earth. They seem impossibly hostile for life, yet sulfur bacteria thrive here. They're anaerobic bacteria, able to survive without oxygen. Now, sulfur bacteria can only exist in restricted environments, hostile to most other organisms. The anaerobic bacteria have an irregular cell wall and contain no nucleus, both indications of its primeval heritage. This is one scenario of how simple anaerobic bacteria may have changed our primordial world. For the earliest forms of life, the absence of oxygen and high temperatures appear to have been the norm. Oxygen was almost certainly lethal to the first living things on Earth, just as its absence is lethal to animal life on the planet today. Then came a crucial turning point. New organisms developed which began to produce oxygen as a byproduct of their more complex respiratory process. As this oxygen continued to build up in the water and atmosphere, it changed the nature of the world. The older anaerobic organisms were either killed by contact with the oxygen or forced into specialized environments. In time, the older organisms only survived in a few environmental niches, while the newer oxygen-producing organisms, such as cyanobacteria, began to dominate the Earth. At Great Slave Lake in northwestern Canada, there are more signs of that bygone age when primitive life forms produced oxygen in enormous quantities. The rocky shoreline has an unusual pattern. These formations were built up over a long period of time, layer upon layer, slowly and steadily. In fact, these fossils are ancient stromatolites built by cyanobacteria. These formations are similar to those discovered in Hamlin Pool and at North Pole, Australia, where the fossils date back about 3.5 billion years. These rocks are only 2 billion years old. But what is surprising about the Great Slave Lake stromatolites is their enormous quantity. Rising steeply from the bottom of the lake, this cliff has been built up from layer upon layer of stromatolites. The cliff extends for 60 miles along the shoreline. The stromatolite layers are nearly 100 feet thick, indicating that they were active for a very long time. 2.5 billion years ago, life on Earth was already producing a great deal of oxygen. When the Great Slave Lake was a shallow sea covered with stromatolite colonies, there was enough oxygen in the atmosphere to support life on land. But the mixture of gases in the air was not the same as in the air we breathe today. Oxygen was less plentiful, and carbon dioxide was much more common. For our modern atmosphere to develop, a great deal more carbon dioxide had to be removed from the atmosphere. One place where we can see this part of the Earth's ancient atmosphere literally turn to stone is China. It's dawn in Guilin. This rugged South Chinese landscape has long inspired artists and poets. It was written of the Guilin region in an ancient poem. The fantastic peaks grow like a jasper forest. The blue waters ripple like silken gauze. These strangely evocative hills run for over 60 miles on both sides of the banks of the Lijiang River. From a distance, the peaks have a misty, dreamlike quality, which is underscored by names like Peak of the Bright Moon and Peak of Solitary Beauty. But on closer inspection, it's clear the hills are composed of rugged, shell-colored rock. The layers run horizontally, with crevices across them. These are the special characteristics of limestone, one of our world's most common types of rock. Limestone is our clue to how the Earth's atmospheric carbon dioxide has remained at relatively low levels. High-quality limestone, suitable for making cement, is quarried here in Guilin. At one corner of the quarry, a small experiment was conducted. When hydrochloric acid is poured over crushed limestone, a violent reaction takes place. A gas is produced that begins to fill the plastic bag. The gas is carbon dioxide. When the carbon dioxide is poured over the candles, it displaces the oxygen and smothers the flames. For millions of years, carbon dioxide has been locked in the hills of Guilin and the world's other limestone formations. Little carbon dioxide remains free in the Earth's atmosphere, but it still has an important effect on the world's climate. This is one of the best places to measure the Earth's atmospheric makeup because it's far from the pollution of any large city. The observatory is located near the top of Mauna Loa on the island of Hawaii. Here, scientists have observed small changes in the carbon dioxide content of the atmosphere for over 30 years. Carbon dioxide makes up only a small fraction of our modern atmosphere, but even tiny changes in its concentration can affect the temperature of the entire planet. The amount of carbon dioxide in the air has been increasing ever since observations began in 1958. Presently, it reaches almost 350 parts per million. This upward trend could have a dramatic effect on our world's temperate climate. Carbon dioxide does not create heat, but it does help trap it. Solar radiation warms the Earth's surface, but very little is absorbed in the atmosphere. The heat is returned to space in the form of infrared radiation emitted by the Earth. Carbon dioxide acts like a blanket, trapping the infrared radiation and causing the climate to warm. This is the greenhouse effect. As the level of atmospheric carbon dioxide rises, so does the temperature. If the gas continues to increase at its present rate, there is growing concern that the average temperature of the Earth could rise 4 to 8 degrees Fahrenheit by the middle of the 21st century. One devastating result of the global warming might be widespread flooding of highly populated coastal areas, like New York City. Based on one theoretical projection, the sea level could eventually rise enough to flood the streets of Manhattan as ice melted from the polar regions. The Earth's environment could change dramatically, based on only a slight change in atmospheric carbon dioxide. The delicate balance of our temperate environment has been maintained in part by the hills of Guilin and many other extensive limestone formations throughout the world. Massive quantities of atmospheric carbon dioxide have been transformed into limestone. A clue to this extraordinary process that created the Earth's modern atmosphere is etched in the face of these hills. The skeletons of ancient corals and other sea creatures are packed closely on the surface. These are the fossilized remains of an extinct organism known as stromatoporoids. They once lived at the bottom of an ancient ocean, along with corals and other marine creatures. Their remains are evidence that this land was once under the sea. It was in an ancient ocean that carbon dioxide was transformed into massive, flat beds of limestone. Later, through an unusual process of erosion, the limestone would evolve into Guilin's unique topography. This region of limestone hills, studded with the fossils of ancient marine creatures, spreads over a large area. In a satellite image of China, the scope of the limestone regions can be seen. When the Guilin area is enlarged, it appears to be mottled with tiny dots. Each dot is the shadow of a limestone peak. Some are several thousand feet high. Extensive limestone regions can be found throughout China, accounting for nearly a quarter of its entire territory. Limestone is particularly concentrated between southwestern China and the Tibetan highlands. At Shilin, 600 miles from Guilin, thousands of fantastic stone towers cover the landscape. Many reach 100 feet in height. These deeply sculpted towers are the result of natural forces. The limestone at Shilin was formed in the sea about 300 million years ago. It was laid down as a thick, flat layer. Since then, recurring rains have carved the unusual shapes through erosion. Small differences in the climate or in the amount of calcium carbonate in limestone can produce entirely different landscapes. Here, the results have been exceptional. But whatever form it takes, limestone can be found in great quantities throughout the world. Limestone is so common on our planet that it's easy to overlook just how remarkable it is. Ocean-dwelling creatures have formed most of the limestone on Earth. Such large-scale deposits on our planet are believed to be unique in the solar system. The four inner planets of our solar system share a common ancestry. They are all rocky worlds and relatively small compared to the gassy outer planets. Yet each is much different from its neighbors. Venus provides an example of what the Earth might have looked like if much of our planet's atmospheric carbon dioxide had not been changed into limestone. Venus is similar in size to Earth, but its atmosphere contains 200,000 times as much carbon dioxide as our world today. A runaway greenhouse effect caused by a thick blanket of carbon dioxide keeps the planet from cooling down. The surface temperature is hot enough to melt lead. It appears that life, as we know it, didn't have a chance to develop on Venus. Without oceans and living organisms, Venus could not develop a temperate atmosphere by transforming carbon dioxide into limestone. Because of the greenhouse effect, Venus will remain a hot, dry, and barren world. Our world is a blue oasis compared to Venus. At the time of our planet's formation, the newly developing oceans absorbed an enormous amount of carbon dioxide from the atmosphere. Much of this carbon dioxide later formed into limestone through pure chemical reactions. The work of making limestone was then taken up by living creatures, a myriad of minute organisms born in the oceans. Even today, marine creatures continue the process. Limestone is still being formed in the oceans of our world, but nowhere is it more evident than here, off the coast of Australia. This is the Great Barrier Reef, the world's largest coral formation. In this protected environment, sheltered by vast formations of coral, life is wonderfully abundant and complex. Large groupers share the clear waters with schools of smaller fish. A balanced ecosystem is maintained by living creatures as they cooperate, compete, and prey on one another. The reef itself is a gigantic mass of limestone. It is continually being formed as carbon dioxide is dissolved in the ocean and transformed by the coral into delicate shapes and massive forms. A coral reef like this is actually a colony of innumerable corallites, or separate minute organisms. Each corallite builds a protective limestone skeleton. In the daylight, coral doesn't look much like a colony of living creatures, but in the darkness of night, the coral comes alive. Now the surface of the colony, which looked like a barren rock during the day, begins to pulsate with white waves. Polyps emerge from minute recesses and start to seek food with outstretched arms. When one encounters its prey, tentacles contract to capture it. The process of making limestone begins with the coral eggs. From October through November, the spring months in the southern hemisphere, coral organisms from the Great Barrier Reef lay their eggs. Egg laying continues for a week after the full moon of October and November, as if synchronized with the lunar rhythm. The eggs are fertilized and become larvae less than a 1/16 of an inch in length. Each one has the potential of growing an outer skeleton of limestone, but at this stage, they are defenseless against predators. Only a few weeks after fertilization, the larvae seek a new home, attaching themselves to the hard surface of rock or other coral. Nearly 2 days are needed to build their protective covering. Time-lapse photography speeds up the process. Sinews full of white particles begin to extend radially. These are crystals of calcium carbonate made from carbon dioxide and the calcium dissolved in the seawater. This is the coral's protective skeleton and the basis of the limestone reefs. Viewed from another angle after 48 hours, the growth of the limestone is clearly evident as the coral begins to build its home. In making their massive limestone colonies, coral polyps also reproduce by a process known as budding off. The new polyp appears next to an existing one and builds its own skeleton. As the process continues over and over again, the coral structure grows upwards and sideways. Beneath the surface of living coral, limestone rock is slowly forming. As the corallites build their limestone skeletons, carbon dioxide is removed from the seawater. It is replaced by additional atmospheric carbon dioxide that dissolves into the ocean. A coral reef develops very slowly, absorbing carbon dioxide as it grows. The reef is formed by countless individual coral polyps. Each polyp is tiny, but if the process continues for 8,000 years, the result can be enormous reefs of limestone. The Great Barrier Reef covers an area of 80,000 square miles and protects Australia's northeast coast from the full force of the sea. But this massive limestone formation is not the only great reef in Australia's geologic past. In the northwest region, far inland from the present shoreline, there is evidence of a similar fossil reef built by marine life long ago. Here, rocky limestone cliffs extend far over the arid plain. They are 250 feet high and rise steeply from the level ground. These cliffs were once ocean reefs, made of the limestone skeletons of minute sea creatures. Today, water is scarce in northwestern Australia, but long ago this arid land was at the bottom of an ancient ocean. This desert range was once a massive reef extending over 600 miles. Viewed from the air, it resembles the modern Great Barrier Reef in both shape and scope. The oldest known limestone was formed by living creatures about 3.5 billion years ago. It was then that stromatolites started to form limestone by slowly building up grains of sand into pedestals of rock. Since then, a succession of living creatures with calcium carbonate skeletons have evolved, including the coral polyps that continue to build today's Great Barrier Reef. Almost all of the limestone on Earth is composed of their remains. In this way, life itself has locked up vast amounts of carbon dioxide in the rocks. Each limestone cliff and formation is an indication that once there was more carbon dioxide in the Earth's atmosphere than there is today. Throughout the world, limestone deposits are monumental storehouses of carbon dioxide, once present in our planet's atmosphere. Below the oceans, living factories are constantly manufacturing more limestone out of calcium and carbon dioxide dissolved in the water. The rock-forming creatures may take many exotic shapes, like the twisted contours of this brain coral. Together with many other marine organisms, they continue the ancient, life-sustaining process that keeps our world temperate. In Guilin, another aspect of the ongoing nature of that process is evident. Water plays the critical role in maintaining the delicate balance of our atmosphere. Underground rivers are common around Guilin. They eat away at these soft limestone hills, dissolving the rock and returning carbon dioxide and calcium back into the water and eventually to the atmosphere. In the labyrinth of caves around Guilin, we can see the process continuing today. The sculptured ceiling of this huge cavern is 230 feet high. The cave is being hollowed out as the action of the water dissolves the limestone walls. At the same time, strange subterranean formations are taking shape. When the carbon dioxide in the subterranean water combines with calcium ions, it becomes pure calcium carbonate. In these caves, the calcium carbonate sometimes solidifies into stalactites. Growing less than a 1/16 of an inch a year, these stalactites are already tens of thousands of years old. In a never-ending cycle, water dissolves the limestone and gradually builds it up again. Water is the key to the cycle that has slowly carved the unusual hills and caves of Guilin. "400 million years ago, southwestern China was a tropical sea, and on its bed, marine life built thick deposits of limestone. The seabed began to rise, and the limestone appeared on dry land. Disturbances in the Earth's crust caused innumerable fissures in the limestone. Rainwater seeped into these fissures and began to dissolve the rock. Steeply tapered peaks appeared, and the water underground flowed in search of an outlet, carving out the caves. As the water table dropped, new caves were carved at deeper levels. For 2 million years, the water level fell as the steady work of erosion continued. This hole shows the position of an ancient water table. When the level dropped, the dissolved opening to an ancient limestone cave was left high and dry. The water table has lowered still further. Today there's a new cave entrance. A surprising volume of water runs down walls and into the underground river. This is where rainwater, seeping into the limestone, flows, while dissolving the rock and releasing carbon dioxide back into the water. The carbon dioxide content of this water is 10 times higher than normal. In some places, the river flows through narrow channels, while in others it merges with an intricate maze of underground waterways. Leaving the darkness behind, the river flows back into the world of light. But its journey is not yet complete. It joins with the Lijiang, like so many other rivers and underground streams in this part of China. As the Lijiang flows through the countryside, it will be channeled into abundant rice lands, support a wealth of fish within its banks and carry the boats of travelers and traders. The great store of carbon dioxide, dissolved from the limestone hills of Guilin, travels with the river down to the sea. As the hills slowly wear away, they release the carbon dioxide that was once locked within the shells of sea creatures millions of years ago. This is how carbon dioxide cycles from the atmosphere to the oceans, to the land, and back to the sea again. In the vast blue waters, it is consumed by reef-building marine creatures, which eventually turn it back into limestone on the seabed. This process is one part of a complex carbon cycle which proceeds in the slow rhythm of our planet. Living creatures, water, rock, and atmosphere are linked together in the process that has made our world and keeps the environment in balance. When one link is altered, the whole system may feel the change. Today, a serious threat to the delicate balance of our atmosphere is emerging. We humans are causing a significant increase in atmospheric carbon dioxide, due largely to the burning of fossil fuels like coal and oil to power modern industrialized society. The sea has not been able to keep pace with the increased carbon dioxide in the atmosphere. The long-term results could have a profound impact. Will our world remain temperate or become hot and barren like Venus? The future may depend on our ability to understand and live in harmony with the environmental cycles that begin and end in the sea.
Coming up, explore the Sea of Cortez on Jacques Cousteau's Rediscovery of the World, next here on TV 12.
Funding for the Miracle Planet was provided by Bull Worldwide Information Systems, unleashing the power of computers for customers on 5 continents.
And by Amoco, fueling the American dream for the year 2000 and beyond. And by viewers like you. The Miracle Planet is available as an educational package. To order, call 1-800-843-0048. This is PBS.
Hello there, Harvey here again. We hope you've enjoyed this fine program made possible by your support and in part by WMGK. That's Magic 103, where you'll find me, Harvey, in the morning. Makes sense. See you on the radio.
Next on Nova. Wild orangutans are humankind's third closest relatives. They live elusive lives deep in the jungles of Borneo and Sumatra. But fewer than 40,000 orangutans still live in the wild. And there is a growing population of orphaned and captive orangutans that are being cared for and then released into the jungle. Orangutans of the rainforest. That's next time on Nova.
Tuesday night at 8 here on TV 12. Ancient Journeys. Tuesday night at 9, here on TV 12.
Nearly 2,000 years ago in Italy, Mount Vesuvius dealt a death blow to the cities of Pompeii and nearby Herculaneum. Today, 2 million people bravely face an uncertain future in the shadow of the same volcano. This is Robert Foxworth. Join me for In the Shadow of Vesuvius, our next National Geographic special.
Wednesday night at 8 on TV 12.
Television's most comprehensive exploration of the AIDS crisis continues with the 4th edition of the AIDS Quarterly, hosted by Peter Jennings. Explore the controversy surrounding the delay of FDA approval.
I don't care what any regulatory affairs, any governmental institution tells me. If this is going to save a life, I'm going to do it.
Wednesday night at 9 on TV 12.
Who in the world is talking to Bill Moyers? Scientists like Jonas Salk, novelists like Toni Morrison, filmmakers like Steven Spielberg. Join some of the most interesting and provocative thinkers of our time. Explore a whole new world of ideas with Bill Moyers.
Fridays at 7:30 here on TV 12. He is one of this century's favorite American actors.
It's just the blood and bone and sinew of this democracy that some great men handed down to the human race, that's all.
His own unique style has touched millions.
Show me the way. I'm at the end of my rope.
Join us as we trace his legendary career.
I've had a wonderful life.
James Stewart, A Wonderful Life, Friday night at 9 on TV 12.
Please send $5 to Butler's Table, care of the New Yankee Workshop, Box E, Bedford, Mass. 01730.
This is PBS.
Local broadcast of the New Yankee Workshop is made possible in part by Force Machinery, distributors of Delta International Woodworking Machinery, and Porter Cable Portable Electric Tools. Porter Cable Electric Tools are available at Force Machinery, 914 East Main Street in Norristown.
Good evening. I'm Sue Serio with your Delaware Valley Weather Report. Weather word for tomorrow is celebrate. More spring-like weather in store for Tuesday with a sunny afternoon and highs going back up into the 50s just like last week. For the days ahead, once again another week of fairly mild temperatures. Clouds prevail on Wednesday and Thursday, and we could see some rain on Friday. I'm Sue Serio bringing you a terrific Tuesday. Stay tuned for the Miracle Planet coming up next.
TV 12 News is made possible in part by Mellon Bank, Delaware, offering a full range of financial services, including home improvement loans and home equity credit lines. Mellon Bank, Delaware, proud to serve the banking needs of the people of the First State. The Cuba of Castro. The Cuba of Cousteau. Cuba on Cousteau's rediscovery of the world, tonight at 9. We're TV 12.
Hello there, Harvey here, as in Harvey in the Morning from Magic 103. All of us at WMGK are proud to join you in supporting the fine programs here on TV 12. So settle back and enjoy, because here comes another one. See you.
For generations, people have wondered about the Earth. What drives clouds high into the afternoon sky? Where does the wind come from? How could conditions on the very edge of space change a barren land into a lush forest? Join us as we explore the mysteries of the Earth's atmosphere. The weather patterns that drench equatorial forests with rain also cause oceans of sand in the great deserts. Patterns in the air, this time on the Miracle Planet.
Funding for the Miracle Planet was provided by Bull Worldwide Information Systems, unleashing the power of computers for customers on 5 continents.
And by Amoco, fueling the American dream for the year 2000 and beyond. And by viewers like you.
From space, the most prominent feature of Earth is not its great oceans or mountain ranges, but the atmosphere that gives our planet its characteristic azure hue. Until recently, people thought of the blue sky as a synonym for infinity. Modern science, however, has revealed that the Earth's atmosphere is a surprisingly thin cocoon. At 1,800 miles an hour, it's just a 10-minute ride to outer space. This is a view from the window of the space shuttle moments after launch. As it accelerates away from Earth, the craft begins to rotate, offering a unique panorama of the Florida coast. Once through the lower atmosphere, the hue of the sky deepens. Above the highest clouds, a succession of blue bands are etched against the darkening horizon. Above the boundary between the troposphere and stratosphere, the temperature is more than 100 degrees below 0 Fahrenheit, and the air so rarefied that no terrestrial creatures can survive unaided. Hello, I'm Bill Curtis for the Miracle Planet. Here in the lush rainforest, it's hard to imagine how different conditions are a few miles above the treetops. This is a moderate world, where the surface temperature hovers in a narrow range, allowing water to exist in liquid form. The reason for Earth's unique climate is all around us, and yet easy to overlook, since it's nearly invisible. The air. Not only does it allow us to breathe, it protects the Earth from excessive solar heat and the most damaging forms of radiation. To understand how our planet maintains its temperate equilibrium, we must return to a time when the atmosphere was radically different, and so was the land. This is Arizona's Grand Canyon. A mile deep and between 4 and 18 miles wide, it is one of the natural wonders of the world. The Grand Canyon is so vast and deep, the vegetation changes from subtropical at the bottom to subarctic at the upper rim. The rugged canyon walls have been carved by erosion. They reveal horizontal bands of sediment. These strata were deposited in different periods of the Earth's past. Each layer is one chapter in the long history of our planet's geologic evolution. Geologists have dated the rocks at the top of the canyon walls at roughly 200 million years old, while those at the bottom of the gorge are approximately 2 billion years old. Along the canyon wall, about halfway down, there is a rust-colored layer of rock. This red bed was laid down about 300 million years ago. Iron-rich sediments combined with increasing oxygen in the ocean to form layers of iron oxide. These layers indicate how far back in time free oxygen existed on the planet. The greatest episode of iron oxidation, 2 to 3 billion years ago, produced the enormous deposits of iron ore that are mined today all over the world. The rusty layers of iron oxide are a colorful example of the Earth's ongoing development. An intriguing aspect of this development is the source of the oxygen in these ancient deposits. Scientists believe that the oxygen was produced by primitive life. Three and a half billion years ago, bacteria-like creatures were already thriving in the oceans. Fossils indicate that these primitive creatures closely resembled the modern oxygen-producing organisms that formed these structures, called stromatolites. The ancestors of these stromatolites once colonized the oceans of the world. These primitive organisms continually release oxygen, which clings to their surface in tiny bubbles. Marine life gradually began taking more complex forms about 600 million years ago. Underwater plants began to develop in the shallow seas. Some evolved into various kinds of seaweed, heralds of the continental forests to come. The oceans were filling with oxygen-producing life, but on land, the scene was quite different. Prior to the emergence of land plants, the continents of the Earth were bleak. Life had been evolving in the sea for perhaps as long as 3 billion years, but the land remained almost devoid of life. There were no green fields, no forests, and no flowers to blanket the earth. On the red deserts, the sand shifted ceaselessly, and the only voice was that of the wind. Why did it take life so long to establish itself on land? One answer lies in the evolving nature of the Earth's atmosphere and its effect on ultraviolet radiation from the sun. Ultraviolet radiation lies outside the spectrum visible to the human eye. We can't see it. Life could not survive on land without a shield from this intense light, which destroys genetic information necessary for cell reproduction. In the ocean, water absorbed the harmful ultraviolet radiation, but allowed the remaining sunlight to pass through for photosynthesis. Organisms like cyanobacteria could then grow and multiply, producing oxygen as a byproduct of photosynthesis. Eventually, the oceans could hold no more oxygen, and the excess gradually escaped into the air. When the oxygen reached the upper atmosphere, it was transformed into ozone. Like water, ozone has the ability to absorb ultraviolet radiation. Gradually, the layer grew thick enough to significantly reduce the amount of ultraviolet light reaching the Earth. Under this protective shield, higher forms of life could finally begin to colonize the land and live completely out of the water. Although the fossil record is incomplete, it appears that the first terrestrial creatures were bacteria. As levels of ultraviolet radiation continued to decrease on the surface of the planet, the first land plants emerged. By the Devonian period, about 360 million years ago, the main groups of higher plants had already appeared, including both spore and seed producers. It was into these low vegetative mats that the first land animals are believed to have crept. We don't know what animal was the first to set foot on land, but it was probably an amphibian. Amphibians, like frogs, are still found in shady, protected areas on the wet margins of the land. Several species have a curious characteristic which may explain how early land creatures survived radiation levels higher than we know today. The eggs of the leopard frog are black on one side, white on the other. The white half contains important genetic material. It cannot block ultraviolet light, but the dark half can. This experiment is designed to test the effect of ultraviolet radiation on frog eggs. When the eggs are exposed to intense radiation, most eggs die. There are only a few scattered survivors. Is it possible that frog eggs use their dark protective cap as a shield against the deadly effects of ultraviolet light? These time-lapse pictures record the movement of normal frog eggs shortly after fertilization. In every case, the egg turns itself so that the dark side faces the light. The eggs instinctively rotate to block harmful radiation and transform it into heat, which aids incubation. Once it has turned its back to the sun, the fertilized frog egg divides into millions of cells. The intricate pattern of life begins to form itself again. The development of a single cell into a tadpole, and finally an adult frog. From the very beginning, it is all made possible by protection from the sun's ultraviolet radiation. 350 million years after amphibians first emerged from the oceans, ozone continues to shield the land, invisibly absorbing radiation. The ozone layer is only part of the protection provided by the Earth's atmosphere. The atmosphere also protects our planet from the full energy of the sun, which strikes heaviest along the equatorial belt. Why doesn't the sun bake the Earth to bare stone, as it has on Venus? Once again, the answer lies in the nature of the Earth's atmosphere. The air that blankets our temperate world dissipates the tremendous energy of the sun through the process of internal motion we call weather. It's dawn on Tarawa Island. Located in the Pacific Ocean at 1 degree north latitude, Tarawa is the most populous atoll of the nation of Kiribati. In tropical regions, the Earth's atmosphere receives intense energy from the sun. From these regions originate the air currents, which drive our planet's weather. The people of Tarawa have long enjoyed a bountiful world of warmth and light. Here, the climate is friendly, and the basic requirements of life are easy to obtain. Although many of the 33 islands in the group grow coconut palms and banana trees, the low atolls are generally not suitable for agriculture. The islanders of Tarawa depend on the sea, pursuing fish in their traditional sail-powered outriggers. Even on the sunniest days, the clouds put on a dramatic show around Tarawa. Time-lapse photography records the energy building within the clouds. As native navigators know, there are stronger winds and more clouds in the late afternoon. This is because the hot tropical sun evaporates large quantities of water from the surface of the Pacific in the tropical regions. When this warm, moist air rises, it cools, and the water vapor in it condenses to form clouds. These are classic cumulus clouds of the lower atmosphere. Born of the sun's energy and carried higher and higher by that same heat, they provide elaborate displays in the afternoon. Often, the swirling clouds rise so high they are transformed into ominous thunderheads. These towering cumulonimbus clouds release tremendous amounts of energy into the Earth's atmosphere. Eventually, all of the water evaporated from the sea returns in the form of rain. The showers on Tarawa are as unpredictable as they are heavy. Yet they are never far removed from the sunshine that also falls on the blue ocean. As the clouds around Tarawa climb higher and higher, the rising air is replaced by wind rushing in from the northeast. Native children learn the ways of the wind with toy boats. A constant breeze blows over Tarawa, and the islanders are masters of the wind as much as the water. The tropical regions are the birthplace of the winds, the zone on the globe to which the winds are continually, if not steadily, rushing. During the era of sail-powered vessels, navigators called these global air currents the trade winds. It was these winds that carried Magellan across the Pacific and Columbus across the Atlantic. The global nature of these trade winds is apparent in these images from space. Driven by the trade winds, clouds encircle the equator in these photographs compiled over 5 days in June. This is just one of the many weather systems that are constantly arising around the equator. In this infrared image, the red and yellow areas indicate warm water. The hot band entirely encircles the planet and powers air movement all over the Earth. Air warmed by the sun at the equator rises, produces clouds, and causes rain to fall. After releasing its moisture, the wind blows along the upper level of the troposphere until it comes down again. This circular movement of air is the most powerful of the Earth's wind systems, spawning not only the trade winds near the surface, but also the jet stream, which occurs 7 miles above the Earth. The trade winds and the jet stream are 2 parts of an immensely complex, heat-driven weather system. Through them and all the other motions of the air, enormous amounts of energy are constantly being transferred from the hot band around the equator toward the polar regions, an estimated 4,000 trillion watts. In this way, tropical heat is distributed to the whole world. Typhoons and hurricanes are the most violent forms of air motions. Their huge swirls indicate that the atmosphere is transporting heat out of the equatorial regions at a tremendous rate. Without air currents, the Earth would be much hotter at the equator and much colder at the poles than it is today. The movement of our planet's atmosphere is one of the main reasons the world is so temperate and hospitable to life. One of the most lush spots on the globe is the rainforest of Kalimantan, Indonesia. Located on the island of Borneo, the exceptionally dense forest is mostly composed of camphor, sandalwood, ironwood, and palm. Beneath their majestic, spreading crowns lies an incredible array of life. The Earth's tropical rainforests contain perhaps 80% of the planet's vegetation, and as many as 4 million different forms of life, including primates like the orangutan. In the tropical forest, the sun seldom penetrates directly to the ground. Everywhere, leaves and tendrils soak up the light and emit oxygen. Some large trees brace themselves above the ground with huge roots called buttresses. This enables them to spread their weight as widely as possible across the often mushy forest floor. Under the green canopy, the temperature is exceptionally constant, hovering around 86 degrees with humidity near 100%. Of course, water is the key to the lush, temperate nature of the rainforest, and it comes to Kalimantan much the way it comes to Tarawa. In the afternoon, the brilliant tropical sun evaporates tremendous amounts of water from the forest below. As the air rises, it cools, and the moisture condenses into clouds, which release rain. Kalimantan receives between 100 and 200 inches of rain a year. About half this moisture originates as mist, evaporated from the rainforest itself. The ecosystem here captures and retains enormous amounts of water. The process has created and continues to maintain one of the most lush environments on the face of the earth. Rainforests are the result of powerful air currents that circle the globe. But these weather patterns create arid deserts just as surely as dense forests. Where the subtropical winds blow over land instead of water, the air becomes dry, creating deserts. These deserts are found on every continent between 20 and 30 degrees latitude, north and south of the equator. The largest is the broad Sahara, swept by desiccating winds. The most devastating wind in the South Sahara is called the Harmattan. The Harmattan originates not in the deserts, but along the temperate Mediterranean coast of Africa. The desert wind begins over Algeria, in a region known for its mild climate. This area receives sun and rain in good measure. The land responds with abundant crops and rich grasslands for grazing. Especially in the winter, winds off the Mediterranean bring substantial rain to the Algerian hills. But the rain clouds do not penetrate far into the African interior. The Atlas Mountains block the way. For 1,500 miles, this natural barrier stretches from Morocco to Tunisia, reaching heights of 13,000 feet. Beyond these mountains, the Sahara Desert stretches for 3,000 miles. Day begins in the world's largest desert. Soon after dawn, the bitter night cold is burned off by the blinding sun. The Harmattan stirs to life. Like the winds of Tarawa, the Harmattan is part of the global trade wind pattern. But instead of blowing over thousands of miles of ocean, the Harmattan blows over land. The wind absorbs moisture from the land, which is not replenished. As a result, the Harmattan becomes a drying force rather than a bringer of rain. Crossing the Sahara from the northeast to the southwest, the wind sweeps huge quantities of sand and dust up into the air. It's not unusual for blinding dust storms to last for 3 to 4 days. The sky is choked with sand and dust, reducing visibility to 200 yards and less. The sand, which often seems to move like a river of the air, is sculpted into dunes, which can reach as high as 800 feet. The actual shape of the dunes is largely determined by the direction of the wind and the supply of sand. But they all share one characteristic: the ability to move. Even when the wind stops, the dunes can stir and shift. Sand that has been blown into unstable shapes falls back under its own weight. There are long Seif dunes, named for the curved Arabian sword. And there are the curious-looking Barkan dunes. These crescent-shaped formations develop in areas where the supply of sand is limited and the direction of the wind is constant. The tips or horns of the Barkan become longer on one side if the wind direction varies significantly, but they always point downwind. Barkan dunes are frequently small, but larger Saharan dunes also respond to the wind. A satellite photograph of this broad desert region shows the powerful effect the wind can have in shaping the land. These sand rows, reaching from the northeast to the southwest, also indicate the direction of the prevailing wind. Here in the western Sahara, the Harmattan is always blowing from the northeast to the southwest. A vast ocean of sand spreads out across the desert. Where does it all come from? One place is the Hogar Plateau. In this bone-dry land, years may pass between rainfall. These high mountains lie at the heart of the Sahara. The region was once covered with granite bedrock, and in some areas, limestone, laid down on an ancient seabed. Later, volcanic eruptions formed the mountains of the Hogar Plateau. They are ancient volcanic plugs of lava, pushed up by violent forces below the surface. Columns of hard basalt are found in areas of volcanic activity throughout the world. But in the Sahara, even these rocky walls must face the inevitable forces that turn mountains into sand. In the cloudless desert, the sun beats down on the rocks, heating some of them to 170 degrees Fahrenheit. At night, because there is no insulating cloud cover, much of the surface heat escapes into space, and the temperature falls rapidly to below freezing. Year after year, this extreme variation in temperature, close to 120 degrees, combines with the chemical weathering of the rock and helps break it down into smaller fragments. Sandblasting by the incessant desert winds continues day after day. The process of erosion goes on century after century until the mountains are finally reduced to grains of sand. Blown on the wind, the sand travels freely until it encounters an obstruction. Many dunes begin as small piles of sand behind a rock or bush. If the sand continues to drift, the individual dunes can grow to mountainous size. Thousands of separate dunes can also merge to cover huge areas, as in the North African sand seas, one of which is larger than France. Here, the wind seems as endless as the sand that it is continually working into new variations of ancient patterns. Each dune, each ripple, is made up of individual grains of sand. Under a microscope, they often appear translucent and small enough to easily pass through the eye of a needle. Most of the desert sands are tiny grains of quartz. The red bits are particles of iron oxide. They lend a reddish appearance to the dunes and help color the dramatic desert sunsets. The iron oxide becomes a fine dust when separated from the quartz. While the heavier sand migrates close to the surface, the finer dust particles are swept high into the atmosphere, traveling far out into the Atlantic Ocean. This is a satellite image of a sandstorm above the Sahara. The sand and dust swept up in the heart of the desert are moving in a giant swirl toward the west, blown along by the northeast wind, the harmattan. Downwind, on the western edge of the Sahara, these recurring patterns of wind and sand are burying the nation of Mauritania. This well is almost 300 feet deep, so deep that it's difficult to draw water without help. Once, water was abundant here, but drought has forced heavy irrigation from the well. Now the water level has dropped so low, only the deepest wells yield life-giving water. These people have come from a village 10 miles away to draw water. They make the 5-hour round trip because the wells in their community have all gone dry. Near the well are a number of garden plots surrounded by palm trees. This cooperative farm has been funded by the government in an attempt to stabilize the lives of the nomads. Even in the Sahara, vegetables will grow if there is enough water. But the dwindling supply of water cannot hold back the force of the desert. The wind blows relentlessly, and sand continually invades the garden area. Date palm trees were planted to protect the farm from the surrounding desert. Today, they're losing the battle. Nomadic tribes once called this highway the Road of Hope. It was a main avenue of trade in the days when water was still plentiful. The nomads hope to expand into the desert following this road. Now they trace the same route back into the towns, trying to escape the advancing desert. Driven away by the wind and sand, more and more people are abandoning their traditional homes and heading for a town downwind. The place in Mauritania where many refugees have fled is Nouakchott. The capital of a country the size of France and Spain combined, Nouakchott is known as the town of blowing wind. It has grown from 12,000 residents in 1964 to more than 350,000 today, as the sand continues to advance on the outskirts of the city. Desert nomads join with millet farmers from the deteriorating agricultural land along the Senegal River. Together, they seek shelter in two sprawling shanty towns that have been called the largest refugee camp in the world. Some pitch tents, while others build shacks of cardboard and tin and scraps of wood. They struggle to survive on the edge of the advancing desert. Sand drifts in the streets of the capital as the Harmattan relentlessly blasts any exposed surface. These people abandoned their villages to come here in search of water. Now they can go no further, for the Atlantic Ocean is at their backs. It is here that the Sahara meets the sea. Swept along on the Harmattan, the sands of the desert are carried far out into the Atlantic. As the dunes march on and on into the sea, they seem barely affected by their passage from one element into another. This is a satellite image of a Saharan sandstorm. Dust particles originating in the middle of the Sahara are blown by the wind toward the Atlantic coast of Africa and beyond, out over the ocean. Every year, more than 250 million tons of sand and dust are carried out of the Sahara by the wind. This is nearly half the total amount blown off all the desert regions of the world. Dust particles are light enough to ascend into the upper atmosphere. Carried by high-altitude winds, dust from the Sahara can reach Asia, Europe, and even the Americas. The movement of clouds gives a clue to the atmospheric link between the Sahara and the rest of the world. Over a 3-month period, numerous cloud formations swirl over equatorial Africa. But in the subtropical regions north and south of the equator, few clouds are evident. It is in this northern dry belt that the Sahara Desert lies. Viewed from the North Pole, the pattern becomes even more striking by overlaying images of clouds generated over the same 3-month period. Cloud formation is slight in a ring that encircles the globe from the Sahara, across the dry Arabian Peninsula, over to India, and finally the desert regions of Mexico and Arizona. From the South Pole, we see a similar pattern. Here, the cloudless belt runs from the Kalahari Desert in Africa to Chile and on to arid Australia. Why are there almost no rain clouds in these regions? To understand the presence of global bands of clear sky and dry lands, we must return to the tropical regions and the water cycle that we saw at Kalimantan and Tarawa. The blowing winds of the Sahara Desert rob the Earth of its moisture. As the wind from the north nears the equator, it converges with wind from the southern hemisphere. The intense heat of the tropical regions warms the air and causes it to rise. High in the atmosphere, the air cools, forms clouds, and causes rain to fall. This is why there is so much precipitation in the tropical region. North of the equator, after the air loses its moisture, it begins to move northward. It drops in altitude and gradually warms again. When the hot, dry winds blow across the land day after day, year after year, they create a desert. In this way, the winds gave birth to the Sahara, a desert equal in size to the entire continental United States. But the Sahara is only one of the desert regions parched by this planetary weather system. The rising and falling air masses are greatly influenced by the rotation of the Earth, causing them to flow around the globe. The air current encircles the Earth in the shape of a donut and creates a dry belt beneath it. It rises at the equator and then descends again around 30 degrees north latitude. A similar air current is in motion just to the south of the equator. Together, these airflows create two dry belts of arid land on either side of the lush tropical region. Rainforests and deserts, polar snowfields, and fields of corn. All the world's diverse climates are regulated by the atmosphere and its weather. Life on Earth has long played an important role in shaping the atmosphere. Today, humans are the dominant life form on Earth. Our activities can help shape the atmosphere and upset the ancient equilibrium. We can see this happening in the equatorial rainforest, where 77,000 square miles of timber are being cut every year. This massive deforestation is causing basic changes in the weather of the tropical regions. Deforestation may even affect the climate of the whole world. Using computer models of the atmosphere, scientists can project what may happen if the deforestation of the world's equatorial rainforests continues at the present pace. The weather chart shows current conditions. Darker areas represent regions of higher rainfall. Notice that at present, the dark blue never disappears from the region of Africa's equatorial rainforests. But what would happen if all trees between 10 degrees north and 10 degrees south latitude were logged? A computer projection reveals the weather consequences of such a course of action. The image on the right represents current conditions, while the one on the left shows the effects of deforestation. After logging, rainfall would decrease in the tropics. By emphasizing the details, we can see the extent of the change. Annual rainfall would diminish to 1/3 its former level. The effects of the African deforestation would also be significant in distant Europe. Here, rainfall would decrease by nearly 20 inches a year. Even the climate of Scandinavia would be affected by cutting all of Africa's tropical forests. We can further gauge the impact by looking at potential changes in soil moisture. Computer images simulate the global effects of cutting Africa's tropical rainforests. The red areas indicate that there would be less moisture after deforestation. The green areas indicate more moisture. In Africa, it's not surprising to see a decrease in moisture content of the soil. Some regions would receive more moisture. But we can also see that the ominous red shadow of drought extends far beyond Africa into the Eurasian continent. Throughout the world, many regional weather patterns would change dramatically according to this projection. 1/3 of the world's equatorial rainforests are contained within the Amazon basin of South America. It is here, as well as Africa, that an intense assault is devastating the tropical rainforests today. Thousands of square miles of timber are logged in the Amazon every year. Commonly, the slash is collected and burned, leaving the earth naked to the elements. Under the tropical sun and rain, vital nutrients are easily leached from the impoverished soil. The land loses its ability to hold moisture and sustain life. At the same time, the climate becomes drier, without the forest to hold moisture and return it to the air. The tropical forests are becoming smoldering wastelands, but humans are not the only cause of massive deforestation. In this tropical region of Southeast Asia, rainforests occasionally burn due to natural causes. In 1983, a forest fire in Borneo became the biggest conflagration of the century. The fire began on the eastern side of the island and then was fanned to immense size by the winds. It eventually consumed an area the size of Vermont and New Hampshire combined. Smoke from the blaze covered the entire southern half of Borneo. But unlike the ravages of slash and burn forest destruction, the natural disaster in Borneo has led to a rejuvenation of life. Just 4 years after the Borneo blaze, the forest had already begun to reclaim the land and heal the scars of the burn. It's hard to believe this is the same region that was reduced to smoking embers. New trees are already reaching 40 feet, and the climbing vines have ventured even higher up in the fire-killed trees. "400 million years after plants first began colonizing the land, life continues to take root on empty ground. Although they may suffer massive destruction, both the plants and animals of the tropical rainforest are capable of an impressive comeback." Life can recover from natural disasters like the Borneo fire. The rainforests have burned and been reborn. This continuing process maintains the global cycle of rainfall and drying winds. The deserts and the rainforests are linked together by the weather patterns that circle the globe. But this intricate system may not withstand the effects of human civilization. Through systematic destruction of the tropical rainforests, we risk upsetting global weather patterns. Unless we understand the far-reaching implications of our actions, we stand to disrupt the delicate balance of our life-sustaining atmosphere. A temperate world of green and blue, or an arid wasteland. More and more, the choice will be ours to make.
Stay tuned now as Jacques Cousteau and the crew explore Cuba following program previews. And be watching for some answers to the question, who built Stonehenge? Wednesday at 9 p.m. here on TV 12.
Funding for the Miracle Planet was provided by Bull Worldwide Information Systems, unleashing the power of computers for customers on 5 continents.
And by Amoco, fueling the American dream for the year 2000 and beyond. And and by viewers like you. The Miracle Planet is available as an educational package. To order, call 1-800-843-0048. This is PBS.
Hello there, Harvey here again. We hope you've enjoyed this fine program made possible by your support and in part by WMGK. That's Magic 103, where you'll find me, Harvey, in the morning. Makes sense. See you on the radio.
Explore the mystic splendor of Bali, masterpiece of the gods, a National Geographic special.
On this isolated dot of land, an extraordinary civilization developed, which remains unique on Earth.
Dances created to please the gods now entertain tourists, yet discover why tourism is actually preserving the ancient culture of Bali.
A National Geographic special, Wednesday night at 8 here on TV 12.
This is something you may never have seen before, the wilderness of Ethiopia. Once it was the Kingdom of Solomon. Today, its forests, soil, and water may be our best hope for ending famine. But look closely, because if we aren't careful, wild places like Ethiopia's Bali Mountains could disappear. See King Solomon's Mountains while you still can on Nature.
Thursday night at 8 here on TV 12.
Next on Nova, the controversial B-2 stealth bomber carries a huge price tag, but looks as small as a bird on a radar scope. It is the latest development in the perennial efforts of armies to hide themselves from their enemies. The art of deception, once simple camouflage, now tests the limits of modern science and technology. Nations battle to be best at the disguises of war. That's next time on Nova.
Tuesday night at 8.
This is PBS.
Local broadcast of the new Yankee Workshop is made possible in part by Force Machinery, distributors of Delta International Woodworking Machinery, and Porter Cable Portable Electric Tools. Porter Cable Electric Tools are available at Force Machinery, 914 East Main Street in Norristown.
Good evening. I'm Sue Serio with your Delaware Valley Weather Report. Weather word for tomorrow is anticipation. It seems that Mother Nature just can't wait for spring, so she's giving us another mild February day. Sunshine tomorrow, high in the mid-50s. For the days ahead, clouds and a slight chance of showers on Wednesday, and it gets much cooler toward the end of the week with a chance of some form of precipitation, maybe frozen, maybe not. I'm Sue Serio bringing you a great Tuesday. Stay tuned for the Miracle Planet coming up next.
As part of its commitment to the community, Hercules and its employees are proud to help bring you TV 12's news programming. Explore with Jacques Cousteau and rediscover the mystery of Tahiti, where the fiery waters give birth to exotic lands, where danger meets paradise. Jacques Cousteau's Rediscovery of the World, this week on TV 12. We're TV 12 WHYY.
Hello there, Harvey here, as in Harvey in the Morning from Magic 103. All of us at WMGK are proud to join you in supporting the fine programs here on TV 12. So settle back and enjoy, because here comes another one. See ya.
For generations, people have wondered about the Earth. How can a vast lake deteriorate into a shallow, muddy channel? How are polar glaciers linked to the burning sands of the Sahara Desert? Join us in a search for ice that flows and ancient rivers buried beneath the sands. We'll follow the trail of ancient glaciers, discover relics of the last great ice age, and living monuments to a time when the desert bloomed with lush green life. Riddles of sand and ice, this time on the Miracle Planet.
Funding for the Miracle Planet was provided by Bull Worldwide Information Systems, unleashing the power of computers for customers on 5 continents.
And by Amoco, fueling the American dream for the year 2000 and beyond. And by viewers like you.
Ice caves like this are formed from avalanche snow that falls during the long mountain winters. Hello, I'm Bill Curtis for the Miracle Planet. In summer, the deep snow melts back, leaving caves and tunnels where streams flow and waterfalls plunge. There was a time, however, when the snow that fell here did not melt. During the last ice age, a permanent layer of snow and ice covered much of North America and Europe. The frozen blanket affected global weather patterns and formed many of the surface features of the planet we know today. These gigantic slabs of rock stand isolated in a wheat field at the foothills of the Canadian Rockies. They testify to the power of ice. Over 30 feet tall and weighing 20,000 tons, these rocks are not originally from this part of Alberta, Canada. In the middle of one of the world's greatest cities stand out-of-place stone monoliths. These large boulders in New York Central Park are entirely different in composition from the native bedrock of Manhattan. In centuries past, people believed that stones like these were the remnants of a great flood, perhaps even Noah's flood. But by the 19th century, another theory began to gain acceptance. Scientists proposed that the massive boulders, called erratics, were transported from the north to the heart of Manhattan by glacier ice. This action also scraped the island down to bedrock, providing a firm foundation for the skyscrapers that followed. 18,000 years ago, glacier ice was at least 300 feet thick over what is now Midtown Manhattan, nearly deep enough to bury the tallest modern towers. Why did this happen? Could it happen again? These questions lead us in a journey back to the last ice age. In that time, the northern and central part of the North American continent was frozen under ice, in some locations as much as 2.5 miles thick. Chicago and New York City would have been buried beneath a massive sheet of ice. But this was just one of at least 10 ice ages that have occurred during the past 1,000,000 years. Today, we can get a sense of what the last ice age must have been like in Greenland. Even during the present interglacial period, conditions here resembled those of an ice age. Greenland is the largest island in the world, 6 times the size of California, and mostly covered with glacier ice. The people of this frozen land depend on the sea for their livelihood. During the short summer that melts passages around the island, they fish for cod, lobster, and halibut among the drifting icebergs. Most of Greenland's ice eventually ends up as icebergs, thousands of which float away from the island every year. The glaciers move like frozen rivers as they spread steadily outward. Following this river of ice inland, we find it originates from an immense plateau of solid ice. Greenland is covered with 2,400 trillion tons of ice. And yet even here, not all water is frozen. In this basin, water from melted snow and ice collects, then plunges over a cataract to vanish beneath the ice sheet. This lake is also made of melted snow. The white bottom reflects the blue color of the sky with unusual fidelity. These meltwater lakes and rivers form on Greenland every summer, resting on an icy bed above the rocky base of the island. In some places, the solid ground of Greenland lies a mile or more beneath the ice. We can explore the depths of Greenland's ice sheet by computer simulation. The image is generated from data provided by satellite observation. Ice covers most of the island, which is over 600 miles wide and 1,500 miles long. Research data gives an unexpected view of the island of rock beneath the sheet of ice. 1/3 of the ground lies below sea level, with the lowest point almost 2 miles below the surface. The land has been pushed down and scooped out by the ice into a bowl-like shape. Ice has shaped the face of the world since the first rains fell billions of years ago. But it is only recently that scientists have begun to understand the mechanics of glacier movement. A great deal of research into the nature of glaciers takes place in Juneau, Alaska, a town close to numerous glaciers. Here, the front of the Mendenhall Glacier reaches a mere 5 miles from Alaska's capital. Riding on the surface are rocks, dirt, and bits of debris carried slowly along with the glacier's advance. The crevasses are etched out in part by meltwater, continually flowing through the ice, which melts, freezes, and then melts again. Following the Mendenhall Glacier back into the mountains, we reach its source, the Juneau ice field. 31 miles from east to west and 62 miles north to south, the ice field is the result of snow falling, collecting, and compacting year after year and gradually forming ice. In places, this ice is nearly a mile thick. Here and there, steep mountain peaks rise from the frozen waste. The Greenland Eskimos called them Nunataks, lonely stones. Despite the name, they're relatively common in the world's great ice sheets. Nunataks rise like sentinels, watching over efforts to unlock an icy record of our planet's past. This glacier research camp is operated by scientists from the United States, Canada, and West Germany. Here, glaciologists examine the annual snow accumulation and changes in composition as it ages and compresses. They do this by digging holes in the snowfield.
We are looking at the wall of a test pit.
One of the scientists who has worked on the Juneau ice field is Professor Maynard Miller of the University of Idaho.
Here, 1 year's accumulation exceeds 6 meters in depth. This accumulation is comprised not only of snow, but of layers of ice that you see here, intervening between large sections of old snow and another material called fern. Fern is the transitional material from snow to glacier ice, the result of the compression of the snowpack due to its weight and the refreezing of percolating meltwater at depth. This metamorphism is a very important aspect of the growth of a glacier.
The accumulated snow has different properties at different depths. These changes can be examined in the wall of snow by descending into a crevasse.
How many ablation surfaces are above you there?
1, 2, 3, 4, 5.
5.
Dark horizontal bands indicate the transitional layers of fern. They are the result of the snow surface being covered by dust during the summer. Each line marks the top of 1 year's accumulated snow. Descending further into the crevasse, there is a gradual change in the properties of the snow. This fissure is 80 feet deep. At the lowest point, the fern has been transformed into glacier ice. Snow is just the raw material for creating glacier ice. In the process, the snow gradually changes. To examine the ice, researchers use a special polarizing plate. Under the glass, the crystals of ice appear brightly colored. An ice crystal lying at a depth of 50 feet has a diameter of 1/10 of an inch. The black areas are pockets of air. At about 100 feet below the surface, the pressure is 3 tons per square foot. The ice crystals grow larger, and the air pockets between them become smaller. As ice crystals increase in size, they tend to align themselves in the same direction. As the weight of ice above increases, the glacier begins to flow slowly down slope. This is the microscopic basis for the movement of a giant glacier. Enhanced satellite images give us an aerial view of the process around Juneau. In winter, the land is buried under a thick blanket of snow. In summer, the snow begins to melt in the low-lying areas and gradually disappears. The snow never melts away completely above an altitude of 3,200 feet, however. It is destined to become glacier ice. Of the 30 glaciers that are fed by the Juneau ice field, the largest is the Mendenhall Glacier. It's the blue area in the center. The glacier flows down the slopes of the coast mountains from an altitude of 5,000 feet to nearly sea level. Some ice melts and forms a glacial lake at its leading edge. Around the lake shore are curious hills called terminal moraines. They're composed of the gravel, sand, and clay carried along by the glacier. The moraines and a lake of meltwater are signs that the Mendenhall Glacier has recently retreated. A journey up the glacier reveals evidence of more debris scattered along the path of this river of ice and snow. Among the rocks, there is a strikingly large example, 6 miles from the front of the glacier. Since the Mendenhall flows at a speed of about 3 feet a day, this gigantic boulder will be carried to the tip of the glacier in about 30 years. Glacial erratics found in New York Central Park or in the wheat fields of Alberta, Canada, must have been transported from their points of origin in this manner. During the late 1960s, scientists from the University of Washington captured in time-lapse photography the movement of a glacier over a 5-month period. Here, in the continuous flow of the glacier, huge masses of ice crack along crevasse lines and finally fall away. The researchers also succeeded in filming the movement of the underside of the glacier. They cut a tunnel 6 feet in diameter through the side of a glacier 320 feet thick. From within the tunnel, they examined the glacier's movement. The reddish-brown area on the lower left is the bedrock. The white and blue glacier flows slowly, appearing to slide over the rock in these unusual time-lapse images. Looking closer, we can see jagged stones broken away from the bedrock. These stones act as the cutting teeth of the glacier, scraping and rasping the bedrock as they pass. The nunataks that rise steeply from the Juneau ice field were sculpted over thousands of years by the action of many glaciers. Often the sides of these peaks were carved out. Typically, the rock was plucked and ground away until, in extreme cases, the force of the glacier either obliterated the mountain or left it standing at sharp angles. Such remnants survive amid a sea of restless ice. At the height of the last ice age, a wintry blanket covered 1/3 of the Earth's land. Today, a warmer climate has melted much of that ice and snow. We are, in fact, in an age between major glacier advances, when global temperatures have moderated substantially. But still, the surviving glaciers continue to press relentlessly forward. This time-lapse film, 5 years in the making, shows the movement along a glacier's leading edge. Here it's apparent that ice and debris are steadily being carried down to the sea on what looks like an immense conveyor belt. The ice sheets which once covered half the North American continent must have flowed like this one. Stones of many sizes would have been scraped from the countryside and dragged under the glacier, leaving marks in the land that still remain. Even in Central Park, surrounded by the tall buildings of New York City, we can find traces of those scars left behind by glaciers of the last ice age. The erratic boulders that stud the park are evidence that a glacier once visited the area. Track marks in the bedrock may tell us about its movement. These gouges were made by the rasping action of rock along the bottom of a huge ice sheet. The grooves testified to the power of the ice and also reveal important information about the direction the ice was moving. One geologist who has studied the phenomenon is Professor Robert Ridke of the University of Maryland.
Here we have some very well-developed glacial grooves in this part of the park. Boulders, cobbles, sand, silt, and clay working along the base of the glacier over long periods of time help to carve these nice depressions. All the grooves are parallel to this line that I'm drawing in one of the grooves. By using our compass, we can find that north is over in this direction. And so clearly the ice, a thick sheet of ice as it flowed over this part of the park, was flowing from the northwest to the southeast, went up over the bedrock, and flowed to the lower end of Manhattan.
Tracing the route of the glaciers that covered southern New York back toward their point of origin, we come first to the Finger Lake region of upstate New York. Here, just south of Lake Ontario, the land is marked by long gouges like the scratches of a giant hand. Altogether, there are 11 members of the Finger Lake group, ranging from 3 to 35 miles in length. As this satellite photo shows, the lakes are oriented fan-like along a north-south axis. The ice sheets carve deep trenches into the soft shale native to the region. Later, after the ice had melted back, the narrow valleys filled with water and became the Finger Lakes. Further north, the trail of the ancient glacier continues. In Canada, heading toward the Arctic Circle, the North Woods thin and the coniferous trees become smaller before giving way to the open tundra. Here, too, are many small lakes. Although they differ in shape from the Finger Lakes, these lakes were also gouged out by the glaciers. As the glacier receded, it left behind numerous erratics. Here, the glaciers have played a trick on gravity. Rocks which once lay on top of the ice were left in a variety of seemingly precarious positions when the ice melted away and returned them to solid ground. Here, the glacier was about 1.5 miles thick at the culmination of the last ice age. The weight of the ice was so great it depressed the land beneath it and cut grooves into the bedrock of the Canadian Shield, the most ancient part of the North American continent. Glacial action here has been vigorous enough to strip the region of most topsoil. This, combined with the cold northern climate, has made it one of the world's most extensive, desolate regions. We are now 745 miles north of New York City. The grooves point still further to the northeast. This is near the source of the former ice sheet. In fact, in the eastern half of the continent, most of the glacial marks point toward one area in northeastern Canada. The source of the glaciers is an extensive plateau called the Labrador-Ungava Peninsula. The journey, which began in New York Central Park, has brought us to a desolate subarctic tableland. The great ice sheet that covered the eastern region of North America less than 20,000 years ago originated here. Today, the land is largely flat, except for valleys like this, which betray its glacial past. These deep clefts were carved out by a glacier. Their U-shaped profile is characteristic of glacial valleys the world over. During the summer, the rocky ground of the Labrador-Ungava Plateau appears briefly. But someday, giant glaciers may once again flow across this vast land, because on Earth, Ice Age glaciers advance and retreat with changes in the Earth's orbit. Responding to the gravitational pull of the sun, the moon, and the other planets of the solar system, the Earth's orbit very gradually changes. It evolves from almost circular to more elliptical, and then back to more circular, here greatly exaggerated. On and on the cycle goes, slowly moving back and forth between the two extremes over 100,000-year intervals. When the Earth's orbit becomes more elliptical, it receives less sunlight in the outer perimeter. and may become slightly cooler. The temperature of the Earth is also affected by changes in the planet's inclination. Today, the Earth's axis is inclined at about 23 degrees, but that angle increases and decreases across 40,000-year intervals. This change can dramatically influence conditions on Earth. When the inclination of the Earth's axis becomes large, the sun's warming rays beat down more directly on a region in a high latitude like the Labrador and Gava Plateau. More of the sun's energy is concentrated on the region, causing a general warming trend with especially hot summers. On the other hand, when the inclination becomes small, the plateau has colder summers because it receives less solar energy. About 115,000 years ago, the Earth approached its maximum elliptical orbit, and at the same time, the axis was at the smallest possible angle of inclination. The Labrador and Gava Plateau was about to greet the first of many cold summers. Oddly enough, the arrival of an ice age was triggered not by cold winters, but by unusually cold summers. The distant sun rose in the summer sky, but it was closer to the horizon and gave less warmth. On the northern plateau, the sun's rays did not melt all the winter snow. The surface of the white snow reflected the sun's warming energy back away from the Earth. As snow-covered areas increased, the amount of solar energy absorbed by the Earth's surface decreased, and the temperature dropped. This phenomenon is known as the albedo effect. Albedo is a measure of reflectivity, in this case, of the land surface. Over time, the albedo effect made the cold tableland even colder, as more of the Earth's surface was covered with snow that reflected solar radiation back into space. In contrast, the sea maintained its warmth much longer than the land because it has a lower albedo, that is, it's less reflective. Warm currents are carried far across the oceans. This is the Gulf Stream, bringing warm water from the equatorial region past the coast of Labrador. When there's a great difference between the temperature of land and sea, a particular weather pattern occurs. It begins when the cold air over Labrador encounters warm, moist air moving north from the Gulf of Mexico. The warm air cools and forms clouds, which in turn drop a great deal of precipitation on Labrador in the form of snow. During the Ice Age, when summers were colder, these conditions continued for unusually long periods. Once this process started and snow began to accumulate, the tendency toward more snowfall became even greater. The region grew colder, attracting more snow from the warm, moist air. The process continued for thousands of years, and in the process, many glaciers were born. Under the accumulating weight, the lower layers of snow turned to ice. As the snow accumulated, the growing ice sheet began to flow under the power of its own cold weight. the white world spread, and another ice age had begun. On the North American continent, one great eastern ice sheet spread toward the Hudson Bay area. Another formed over the rugged mountains of western Canada. These glaciers combined briefly to form a huge ice sheet almost 2.5 miles thick, reaching from the Atlantic to the Pacific. The Eurasian continent also developed a similar sheet of ice, and before long, 1/3 of the Earth's land was buried under glaciers. Over the last million years, the Earth has experienced at least 10 distinct ice ages, separated by relatively short warm spells. These ice ages dramatically altered global weather patterns. Northern regions that are now the world's breadbasket were locked in the grip of frigid winters and cold summers. Shifts in the climate eventually brought life-giving rains to some dry desert regions. One area that was transformed in this way is the Sahara Desert. Tassili-Niger is located in the middle of the Sahara Desert. But there is much evidence here of a land that was once green and well-watered. The name Tassili-Niger means plateau of flowing rivers, and indeed many old river courses and canyons can be found in the rock. Water carved the stone towers and other formations by eroding the relatively soft sandstone. There is also considerable evidence of wind erosion here in the pitted surfaces of the exposed rock. Because of its weight, the sand cannot easily rise above the ground more than a few yards, so this erosion is limited to the lower walls. But the signs of water erosion are widely visible on the walls. Further evidence that water once flowed here has been discovered by satellite observation. In November 1981, the space shuttle trained a special side-scan radar device on the Sahara Desert. This instrument emitted a signal that could pass through the desert sands because of the uniformity and dryness of the sand grains. The experiment was designed to examine the structure that lies beneath the surface. The radar penetrated to a depth of almost 20 feet. The images that emerged from the 27-mile-wide scan of the Sahara were surprising. Underneath the smooth sand layer, many ancient drainages and floodplains appeared. In fact, there were many river systems, some as big as the Nile, when the Sahara enjoyed intervals of a wetter climate. From a blazing desert to a green watered land and back again, the face of the Sahara has changed many times. On this rock wall, there are more clues to the Sahara's wetter climate, which followed the last ice age. People created many wall paintings between 6,000 and 2,000 years ago. They tell us much about the changing lifestyle of the people who occupied the region. And they give us a glimpse of the changing Sahara itself. The most recent picture is of a camel, which suggests a dry climate like the one today. Prior to this period, the wall painters depicted different animals. Perhaps wishing for an abundance of livestock, ancient farmers painted many cows around them. Here we see cattle grazing, people cooking and chopping wood. Significantly, people are shown caring for their animals. These people were herdsmen. And this is the inside of a native home. The dark image is a central bed surrounded by walls. These are the paintings of a people who are becoming settled. But before this time, the wall paintings show nomadic hunters pursuing now extinct beasts. The age of these animal paintings indicates that as long as 12,000 years ago, the post-Ice Age Sahara must have been a green world where people lived among trees, flowers, and flowing streams. The climatic changes at Tassili Niger are the result of fluctuations in the two great dry belts that circle the globe above and below the equator. As the polar ice caps expand and contract due to variations in the Earth's orbit and tilt, the dry belts move accordingly and influence the size and location of the deserts. Let's look more closely at the situation in the Sahara and its relationship to the polar ice caps. Around 18,000 years ago, the glacier ice reached its maximum coverage, both in the northern and southern hemisphere. The dry belts were then pushed toward the equator. This gave areas in the northern Sahara, like Tassili Niger, a wetter and more moderate climate, similar to what the Mediterranean enjoys today. But as the Earth's orbit continued to change slowly, the glaciers began to retreat. Responding to this change, the dry band of the Sahara expanded gradually northward to the shores of the Mediterranean. At the close of the Ice Age, the general warming trend brought life-giving rains into the southern Sahara. Streams flowed, and the Sahara became a broad savanna where life could flourish. But as the Earth's orbit continued to shift, the climate of this region once again became drier. In historical times, the southern limits of the desert have fluctuated, first north, then south, occasionally bringing severe drought to inhabited areas. Even today, the desert is still spreading south, and it's hard to imagine a time when cool streams flowed in the Sahara. Living proof of that long-vanished Sahara still remains. This cypress tree is one of the few survivors from the time when the Sahara was green. It sprouted over 4,000 years ago, before the rise of ancient Egypt. The glaciers had long receded, but rains still fell in the Sahara. The ancient animals and the men who pursued them gradually vanished from Tassili Niger. The giant old tree, rooted deep in the desert soil, has survived the changing face of the Sahara. But here in the southern Sahara, there is evidence of a different force within the Earth itself that also has changed this land from desert to forest to desert again. These are the petrified remains of trees that grew in the Sahara 100 million years ago. Over time, each cell of the tree has been replaced with silica, preserving the shape in the form of rock. Some of these petrified trees measure 65 feet in length, testifying to the well-watered nature of this region during the age of the dinosaurs. These long-term changes in the African climate result from continental drift. While the dry belts have moved north and south due to changes in the Earth's orbit, the continents have moved as well. 200 million years ago, the region we know as the Sahara Desert was quite far from its present location. Africa was located much closer to the South Pole. Driven north by the process of plate tectonics, the heart of the Sahara first passed through the dry belt region of the southern hemisphere. 100 million years ago, the Sahara reached the tropical region of the equator. In that age, tall trees grew, covering the land with great forests. But it would not remain a lush region. Very slowly, the Sahara moved into the northern hemisphere's dry belt, bringing a general return to desert conditions. These have been heightened over the last 5,000 years by a gradual shift in the dry belt itself. The most dramatic changes can be seen along the southern fringe of the Sahara. Not long ago, this area was the bottom of Lake Chad. These people are going fishing. A pier is located near their village, but the water no longer reaches it. Now they have to haul their boats to the lakeshore. About 30 minutes travel by car from the village, there's a fish market located on a withered arm of the lake. People come here from around the region to buy fish caught in Lake Chad. A waterway leads to what is left of the lake. Along this section of the channel, boats must pass closely in the shallow water. Fishermen are numerous. They compete for the fish that remain in this narrowing passage. Stringing their lines, they float along, hoping for a strike. After an hour of paddling, the waterway narrows to a shallow channel of muddy water. Some of these travelers were on their way back from Lake Chad. To reach this point, it was a 4-day journey from the present shores of the lake. They say that Lake Chad was here just 1.5 months ago. The water level in this South Saharan lake is falling that fast. The process is particularly evident in these false color satellite photographs. The red images are vegetation. In 1973, Lake Chad was as big as the state of New Jersey. Because it is such a broad, shallow lake with no drainage outlet, Lake Chad is greatly affected by evaporation, which is more powerful in this part of Africa than anywhere else in the world. The geologic record reveals that the water level has fluctuated widely in the past, but never more than it has during the last 2 decades. In 1982, 9 years after the first photograph, half of the north side of the lake has changed to a reddish-brown color. This indicates that much of the lake is drying up, replaced by growing plants. Swamps are the black areas, and only the southern part of the lake remains. As the months pass, the swamps continue to dry up. In 1984, the swamps have all but disappeared, and the lake has diminished to 1/10 of its former size. Global forces are at work as Lake Chad is being claimed by the expanding Sahara Desert. This is a unique period in the evolution of our world's climate. Two contradictory forces are at work. One is a natural cycle. The other, a result of human activity. Natural changes in the Earth's orbit suggest that over the long term, our planet will be getting colder. We are slowly heading for another ice age. And yet the Earth is showing signs of a short-term warming trend that may be due to carbon dioxide building up in the atmosphere. This is the increasing greenhouse effect, which has come about since the Industrial Revolution, chiefly as a result of burning enormous amounts of fossil fuels. So though we may be heading slowly for another ice age, we are now in a warming trend, influenced by humanity. Global weather patterns are changing, and in some areas, the deserts are spreading. We can see the deserts advancing today in places like Mauritania. A few thousand years ago, this South Saharan country contained many small, shallow lakes. Today, most are dry and live on only in the language and place names. One such place is Nouakchott, the capital of Mauritania. The suffix "chat" refers to a salt lake that has long since vanished. This is the edge of Nouakchott today, the bleak destination for thousands of refugees fleeing the expanding desert. It, too, has been overrun by blowing sands. In lulls between the windy blasts, people begin to build their houses. They dig a hole in the sand to support a post. To keep the hole from caving in, they harden it with drops of precious water, which now must be drawn from deep wells. This is life today in the South Sahara as people try to hold on in the face of a world that is growing ever more hostile. We don't know how far the Sahara Desert will spread or when it will begin to retreat. But one thing is certain, the face of our planet is continually changing. For billions of years, natural forces have brought frozen glaciers and arid deserts. Now, through our actions, we are becoming a global force to change the face of our miracle planet.
Be sure to stay tuned as Jacques Cousteau and the crew of the Calypso travel to Tahiti, coming up following program previews. And join us as we take you to the temples of Solomon on Ancient Journeys, tomorrow night at 9 here on TV 12.
Funding for the Miracle Planet was provided by Bull Worldwide Information Systems, unleashing the power of computers for customers on 5 continents.
And by Amoco, fueling the American dream for the year 2000 and beyond. And by viewers like you. The Miracle Planet is available as an educational package. To order, call 1-800-843-0048.
Hello there, Harvey here again. We hope you've enjoyed this fine program made possible by your support and in part by WMGK. That's Magic 103, where you'll find me, Harvey, in the morning. Makes sense. See you on the radio.
Waiting for winter to pass you by? This year, spring comes early with Bill Moyers. From D-Day to the Rhine.
What's it like to be looking at a tank like that? Or have a tank?
Not good.
Have a tank.
The Public Mind, a world of ideas, and Joseph Campbell and the Power of Myth.
Total
interfere with my judgment.
Look, it's not him you're protecting, it's yourself. You just can't bring yourself to tell him. Look, for God's sake, Uncle, this isn't a case of raised blood pressure we're talking about. The man has a limited time. He wants to know what to do with the rest of his life.
And that's what I'm supposed to tell him.
Look, he knows he's got AIDS. Now, every day he doesn't hear anything just makes him more certain. Okay, so we can't cure him, but at least we can give him something to modify the effects.
David, one of the cardinal rules of medicine, don't jump to premature conclusions. There's a report on Colin. The AIDS test was negative.
Multiple sclerosis.
Yeah. And that means he might not have another attack for 20 years.
And on the other hand?
On the other hand, the worry of knowing it might hit him at any time could only make things worse. Don't you agree?
Yes, of course.
Oh, so you're right. I am afraid to tell him. Would you be prepared to take that gamble?
Explore the wondrous world around us on Nature, Thursdays at 8 on TV 12.
Hello there, Harvey here, as in Harvey in the Morning from Magic 103. All of us at WMGK are proud to join you in supporting the fine programs here on TV 12. So settle back and enjoy, because here comes another one. See ya.
For generations, people have wondered about the Earth. How have we affected the world that is our home? Did the land use of ancient civilizations hasten their fall? And what legacy is modern industrial society leaving for future inhabitants of the Earth? Join us for a look at how humanity has shaped the Earth and its atmosphere. We'll examine the decline of ancient Egypt, investigate the threat of the ozone hole, and find out how both are significant for our world as it nears the 21st century. The home planet, this time on the Miracle Planet.
Funding for the Miracle Planet was provided by Bull Worldwide Information Systems, unleashing the power of computers for customers on 5 continents.
And by Amoco, fueling the American dream for the year 2000 and beyond. And by viewers like you.
From space, The clouds above the Earth trace delicate patterns over land and sea. Below, the pattern of human activity marks the surface of the planet. In the barren lands of the Sahara Desert, there is a strange grouping of circles. Each circle is a field, irrigated with water from wells deep beneath the desert. In the Sudan, farmers draw water from the Nile to grow their fields of cotton. This patchwork of farmland is part of an immense agricultural project which combines thousands of acres under unified management. Each of the green rectangles is nearly 2 miles long. On the other side of the globe, similar projects have also made an impact on the landscape. These mile-wide circles are irrigated plots in the desert of eastern Oregon. Farming is not the only human activity visible from space. In many parts of South America's Amazon jungle, deforestation has become an obvious surface feature. In this satellite image, the red represents bare logged areas. They're expanding year by year as the forest is being destroyed along the branching network of roads. Even from 120 miles in space, it is evident that humans have become a major environmental force all over the Earth. We humans have made a great impact on our world in a relatively short time. Hello, I'm Bill Curtis for the Miracle Planet. In just a few thousand years, we have grown powerful enough to affect the global environment, from the upper atmosphere to the ocean floor, from the great deserts to the tropical rainforests. Of all creatures on Earth today, Homo sapiens will have the greatest influence on the future of our planet. But against the backdrop of Earth's long history, people have lived on this planet for only a brief moment. To appreciate the contrast between our short stay on Earth and our extensive impact on the environment, we must return to the early days of our planet. Four and a half billion years ago, meteorites rained down on the surface of the newborn Earth. The heat of their impacts and the internal heat of the planet released vast quantities of water vapor into the primeval atmosphere. When the planet finally began to cool, the water condensed and fell as rain. The rainwater collected into vast oceans, which eventually covered the Earth. It was under the protective blanket of the sea that life was born nearly 4 billion years ago. The first forms of life produced oxygen as a waste product. But eventually, living creatures developed which needed oxygen. Life began to evolve rapidly, becoming increasingly complex. The oxygen accumulating in the seas gradually escaped into the air, where it radically transformed the atmosphere above the Earth. The oxygen reacted with sunlight to form a thin layer of ozone high above the Earth. The ozone began to protect the land against ultraviolet radiation, making it possible for life to emerge from the sea. 400 million years ago, green plants spread along the shores of the Earth. Gradually, the continents were covered with vegetation. The Carboniferous period was a time of gigantism, when huge ferns grew nearly 100 feet high, and dragonflies measured 2 feet across. This period, which lasted more than 60 million years, was a time of global transformation. The climate of the Earth was changing, as were the positions of the continents. 200 million years ago, Africa and India split apart from the ancestral continent, Pangaea. Gradually, the Carboniferous swamps filled with sediment from countless generations of decaying plants. They would become the storehouses for the coal and oil we use today. During the most recent geologic epoch, glaciers replaced swamps as a distinctive feature of the North American landscape. And at least 10 times during the last million years, glaciers have expanded to cover a significant portion of the globe. These ice ages have witnessed the extinction of many species and rise of others. Among the creatures which have prospered in the wake of the most recent ice age are human beings. This drawing of a wild goat, called an ibex, was painted on a cave wall near Cognac, France, approximately 20,000 years ago. On a wall nearby, some of the ancient artists left their own marks. These are handprints. They record the efforts of individuals who stood here at the dawn of Homo sapiens. At that time, the human population of the Earth was relatively small, perhaps fewer than 5 million. But even then, people were beginning to reshape the face of the planet. During the Neolithic period, people began to make significant changes in their world, establishing communities like this one near the Dead Sea at Jericho. These are the remains of the walls of Jericho, excavated by archaeologists. About 2,000 people once lived in the ancient city, considered one of the world's oldest settlements. Its economy was based on agriculture, judging by the wealth of farm implements found at the site. This mortar and pestle was used to grind wheat into flour for the families who came together to live and work within the walls. This rare sickle, crafted of bone and stone, was probably used to harvest grain from the fields outside the town. Agricultural communities spread slowly from the Middle East to neighboring regions, including what is now the Sahara Desert. Even in the central Sahara, we find evidence that people farmed these lands several thousand years ago. A herd of cows has been skillfully carved into the desert cliff. Wild animals that once roamed the area are depicted as well. This giraffe is rendered in life size. We know from these carvings that the Sahara was once much wetter than it is today. In those days, a broad green savanna covered what is now the world's largest desert. The sands, which seem so eternal, are in fact transient. They come and they go, driven by long and short-term climate changes. The current spread of the desert is linked to long-term global climate changes following the last ice age, although humans have accelerated the natural process of desert expansion. As the rains fell less and less often along the North African coast, the Sahara Desert spread south, west, and east. More and more, the expanding desert forced tribes of farmers into fertile river valleys. The Bible relates an account of these migrations in the first book of Moses. The ancestors of the Israelites left a dying landscape and journeyed to the valley of the Nile. While the desert was spreading, the Nile Valley remained green and fertile. Around the Nile, this influx of immigrants helped provide both the skilled craftsmen and slave labor that built one of the world's first powerful civilizations, the Egyptian Empire. The pyramids, erected around 2500 BC, were majestic monuments to Egyptian god-kings. They represent the great golden age of the ancient Egyptian Empire. But it was also a time when great damage was done to the Nile River Valley. The famous Sphinx of Giza symbolizes the pharaoh Chephren in the form of the sun god Ra. When it was built, the Egyptian landscape appeared much different than today. The desert sands had not yet reached the base of the pyramids. In this fertile valley, the Egyptians began using the waters of the Nile to irrigate their fields. Under the authority of the increasingly centralized Egyptian state, the trees were felled and the marshes drained for farmland. The pharaohs conquered the people of many nations, expanding their empire. They would use the newly acquired workforce to conquer the land as well. This bas-relief from the tomb of an Egyptian pharaoh depicts a large-scale agricultural scene along the Nile thousands of years ago. It was this rich farming society that built the powerful civilization symbolized by the pyramids. When the pharaohs ruled, irrigation was practiced on a wide scale. Marshes were drained and trees cut to make room for more and more farmland. But even as the ancient Egyptian civilization reached its zenith, the desert was encroaching on the edges of the Nile Valley. Eventually, intensive agriculture depleted many fields. Crops would no longer grow, and the rich black land gradually degenerated into the red land of the desert. From ancient times, it seems that human civilizations have affected and sometimes severely altered the natural environment that at first had sustained them. The Mediterranean Sea has witnessed many civilizations since the ancient Egyptian Empire. The cultures of Greece, Carthage, Rome, and Byzantium flourished for thousands of years among the blue waters and sun-drenched islands. This was the cradle of Western civilization. Today, we know these vanished civilizations much the way we know the ancient Egyptians, from ruins, like the Temple of Poseidon in Greece. Archaic temples are not the only ruins left by the ancients of the Mediterranean. They also left a legacy of land exhaustion and desertification that is still evident thousands of years later. Only ruins remain of Ephesus, an ancient Greek city in what is now Turkey. During the 4th century BC, its wealth was proverbial, and its temple to Artemis was considered one of the 7 wonders of the ancient world. This amphitheater, with a seating capacity of 24,000, gives a hint of the glory of ancient Ephesus. Long ago, this was a magnificent library. Scholars gathered here from cities all around the Aegean to study science and medicine. St. Paul came to this Mediterranean port to visit one of the earliest Christian congregations. Ephesus was a center of learning and culture in the ancient world. But in the end, Ephesus declined into obscurity, partly as a result of its own success. In fact, history rarely provides such a clear example of how human action affects an environment. Soil samples from the region may shed some light on the fate of Ephesus. Each sample contains pollen from plants and trees that once lived here. The core samples were taken at different depths and correspond to various time periods in the natural history of the region. Researchers have been reconstructing the stages of Mediterranean civilizations by studying changes in plant life over a 4,000-year period. Because each type of plant produces a unique form of pollen, soil samples provide valuable clues to the vegetation of ancient times. Following the evidence of the pollen, we can trace the evolution of the environment around Ephesus. This is a microscopic view of wheat pollen. It was found in a soil sample dated 2,000 years ago. Many samples from the region indicate that wheat pollen was common in the soil when Ephesus was at its zenith. From the grain, bread was made to feed the growing population of this coastal trading center. At that time, wheat was commonly grown on the hills around the city. The upland fields near the mountains must have been widely cultivated, but even these fields would probably not have provided enough grain for the city's peak population. But the land was not always heavily cultivated. Earlier, another type of plant dominated the hillsides. In soil samples from this period, the pollen of plantain is common, while wheat pollen is rare. Plantain is a grass typically found in open fields and pasture lands of the European continent today. From this, we can deduce that goats and sheep probably grazed on the land around Ephesus before the fields were plowed and planted with wheat. Further back in time, the pollen of yet another plant predominates in the soil samples. 4,000 years ago, the pollen of oak trees was very common. This indicates that prior to the arrival of people, Oak woodlands covered the land that would become Ephesus. By analyzing pollen grains, it becomes apparent that the environment of Ephesus changed from forest to pasture to farmland over a 2,000-year period. These changes were caused by human actions intended to make the land more productive. But ultimately, they contributed to the ruin of a thriving port city and the land that supported its people. A fatal mistake at Ephesus was interrupting the natural water cycle. Before the arrival of people and the founding of the small village that became Ephesus, the seasonal rains fell on wooded slopes. Some of this moisture quickly evaporated or ran into rivers and streams, but a great deal was retained by the forest. Slowly, over many months, this stored moisture was released, moderating the difference between the wet and dry seasons. But when the forest was cleared for pasture, a rapid change began to occur in the natural environment. The grassland could not retain as much of the rain, so more water was released as runoff. Lacking the protection that was once provided by the forest, the soil began to erode. This process accelerated when pastures were plowed and planted with crops like wheat. Eventually, barren, infertile land was all that remained from what had been a forest on the hills around Ephesus. This was just the beginning of the environmental problems Ephesus caused for itself. Erosion carried soil down the Caister River, threatening the city's deep harbor with accumulating sediment. In the Roman era, the flow of sand and silt reached its peak, causing many inlets to silt up and clog. As the centuries passed, the effects of deforestation, grazing, and farming took their toll on the city's waterway. At least 4 times, the city was relocated closer to the mouth of the bay. But despite repeated dredging, the harbor was too shallow by the 9th century AD to accommodate the Byzantine fleet, and Ephesus declined into obscurity. Like the hills around Ephesus, this coastal region of the Mediterranean was once covered with vegetation. Here, too, deforestation has been a major factor in creating a barren landscape. But this is only the first stage in the continuing process of desertification. The problem of erosion is worsened by large herds of goats and sheep that roam the logged hills. Because they're sure-footed, these hardy animals can live on slopes too steep for cattle. They graze the sparse vegetation down to the roots. When large herds overgraze a hillside, the ground cover is destroyed, and gradually the desert claims the land. Even with the resources of modern civilization, it's easier to degrade green woods and fields than it is to reclaim the desert and make it bloom again. The tragic decline of Ephesus is only one instance of what can happen when humans radically alter the environment without considering the consequences. Around the Mediterranean, the process of deforestation, overgrazing, and farming has repeated itself over the centuries. The need to replace depleted natural resources may have been one of the factors that drove Roman civilization north into barbarian Europe. Conquering Roman legions crossed the snow-capped mountains of the Alps, established garrisons as far north as England. The imperial Romans found scattered barbarian settlements secluded in a vast realm of virgin forest. The rich wilderness must have seemed like an endless source of natural wealth to the Mediterranean cultures, which were facing depleted resources at home. And so the Romans began their move north into the fertile forest land of oak and beech and spruce. As the Roman Empire declined, missionaries and migrants brought with them their new religion, Christianity. Christian communities began to spring up all over Europe. Trees were cut and the foundation laid for the first building, often a small church in the middle of a forest. Then, by cutting more trees, enough land would be opened up to enable people to begin farming. Soon more and more villages dotted the countryside. Over the centuries, the village would become a town, and perhaps even a city. Nördlingen in West Germany is one such village. This modern town began as a small settlement in the forest. The church at the center of the village is encircled by houses. Surrounding them, the town wall stood as the main defense against marauding enemies. Inside this protective circle, the people of Nördlingen prospered. To support the towns, farmlands were cleared beyond the walls. Trees were cut and fields plowed as the farms expanded into the surrounding country. Once again, the process of deforestation and the grazing of animals increased, this time in a more northerly setting. In Paris, the Cathedral of Notre Dame stands on an island in the Seine River. On this site, the early Christian settlers built a church in the 6th century. The great cathedral was constructed later, as the city of Paris grew up around it. Today, Notre Dame is surrounded by a great metropolis that spreads out to the horizon. This is a satellite image of modern Paris. The red area with the Seine winding through it represents the heart of the city. Small areas of dark green around the outer margin are what is left of the forest. The great forests around Paris were long ago cut down and cleared to support the growing city. Berlin presents a similar satellite image, with an important exception. Like Paris, it began as a village in what was once a dense European forest. By the end of the 18th century, most of the surrounding timber had been felled. But today, dark green patches are scattered in the surrounding countryside. They are evidence of the popular concern over deforestation that has prompted the planting of many new trees. London provides a much bleaker picture. The city spreads broadly on both sides of the Thames. There is less green evident here than either Berlin or Paris. The tall trees around the capital of this island nation have long since been cut down. Taken as a whole, the Europeans have followed the same path as the Romans, the Greeks, and the Egyptians. Like its predecessors, European civilization has caused tremendous environmental damage. But unlike those before, it postponed the natural consequences by expanding its reach to truly global proportions. From the Mediterranean to Europe and on to America, the search continued for land to clear and untapped natural resources to fuel the expansion of Western civilization. Today, the island of Manhattan is forested not with native ash and oak, but rather with the concrete and steel towers that form the city's distinctive skyline. People pack into skyscrapers to work and live in America's largest city. But as the population increases here and around the world, the demand for natural resources has never been greater. In many ways, our culture resembles the civilizations of antiquity. We have cleared the prairies and forests for farmlands and sprawling cities. We demand ever more natural resources to fuel our factories and homes. From automobiles to plastics, our industrial society is based on the manipulation and consumption of fossil fuels. We've been extremely effective in our global search for coal and oil, but we are rapidly depleting these natural resources. Tremendous buried reserves of coal and petroleum still remain in many regions of the world, but they are created very slowly. The natural formation of coal and oil requires millions of years and exceptional geologic circumstances. One place where it is possible to witness the coal of the future being created today is Okefenokee Swamp in Florida. Here, countless islands dot a vast marshland. Marshes like this were the scene of the tremendous plant growth that produced the coal people mine today. 350 million years ago, during the Carboniferous period, large areas of North America were submerged beneath a shallow sea with extensive marshes along the shores. Plant life in these shallow swamps was incredibly luxuriant. Huge ferns and fern-like trees, giant horsetails, club mosses, and primitive conifers grew thick in many regions of the world, including what is now the East Coast and upper Midwest of the United States. A record of this era lies in the vast coal fields of Appalachia, Wales, and England, and the Saar Basin of continental Europe. Today, the conditions that produce these coal deposits can be found in the marshlands like the great Okefenokee Swamp. A core sample provides a record of the coal forming process that begins with dead plants. Over time, this partly decomposed matter settles on the swamp floor, forming a black substance called peat. Every 20 years, a little less than half an inch of peat accumulates on the marsh floor. At Okefenokee, the peat bogs are 16 feet thick. This sample represents about 2,000 years of decomposing plant life.
Beginning of the cypress swamp here, pieces of wood, a forest, continuing forest. Perhaps around 2,000 years ago, the beginning of a dry, very dry period. Many fires, pieces of charcoal. The cypress swamp was destroyed, and we ended up with a marsh. It was transformed into a marsh with aquatic plants, no wood, only roots and fibers of aquatic plants.
Over a very long time, coal gradually forms when peat is sufficiently compressed by the enormous weight and pressure of the growing deposits above. The Okefenokee is slowly making new fossil fuel, just as the ancient swamps formed the coal to fire the early furnaces of the Industrial Revolution. Today, the use of fossil fuels has spread to every facet of modern life. In the heartland of America, here in Nebraska, fossil fuels enable farmers to do everything from fertilizing to harvesting to pumping water for irrigation. Modern agriculture is extremely expensive, but it has allowed America and other developed countries to postpone the effects of environmentally destructive practices. In some areas of the American Midwest, an estimated 1.5 bushels of topsoil is lost for every bushel of corn produced under modern farming conditions. The soil of the Midwest is as deep as it is rich, but in the century and a half since the prairie was opened to the plow, in many areas, half of it has eroded away. Production has remained high, however, through the use of petroleum-based fertilizers and highly mechanized farming. Today, American agriculture is more costly and energy-intensive than ever before. Our society is dependent on the alchemy of energy more than any previous culture. We can transform crude oil from the Earth's crust into fuel, into clothing, and plastic products that crowd the closets of our homes. We burn enormous amounts of coal and oil to fire the engines of modern society. For the first several thousand years of civilization, people relied on simple, easily accessible energy sources. The old cultures were dependent upon farming and the natural productivity of the land. As the land failed, so did many ancient societies. But as modern civilization advanced, we developed new technologies and methods for tapping ever more resources. Today, each inhabitant of an industrialized country consumes as much energy in one day as a citizen of ancient Rome used in a year. As our populations increase and our cities grow, we manage to prolong the lifespan of our modern civilization through the consumption of great amounts of fossil fuels. It appears that we have overcome the limitations that faced earlier cultures. But we are only beginning to recognize the new limits that our society must face. The lights of streets and buildings illuminate this satellite view of the Great Lakes region of North America. Liberal consumption of energy has brought us a comfortable lifestyle, but it also suggests that modern civilization's impact is beginning to affect the whole Earth. Located in the middle of the Pacific Ocean, the Hawaiian Islands are far removed from the centers of modern civilization and pollution. Yet even here, among the clouds that cloak the peaks of Mauna Loa, the effects of civilization are being meticulously recorded. This is the Mauna Loa Marine Atmospheric Observatory. Scientists have observed a gradual increase in the concentration of carbon dioxide in the atmosphere since observations began in 1958. Prior to the Industrial Revolution, the concentration of carbon dioxide in the atmosphere was around 280 parts per million. Now, it's nearing 350 parts per million. This trend could have a major impact on our world. In an effort to predict future global climatic conditions, Professor Manabe, a scientist working at Princeton University, uses a supercomputer. His theoretical program calculates how increasing levels of atmospheric carbon dioxide will affect the Earth. According to some projections, levels of carbon dioxide might reach as high as 600 parts per million by the middle of the 21st century. Carbon dioxide in the atmosphere traps the sun's heat as it is released by the Earth's surface. An increase in carbon dioxide of this amount would raise the average temperature of the Earth 4 to 8 degrees Fahrenheit. Manabe's computer simulation illustrates what might happen in North America if the average temperature rose by just a few degrees. As temperatures rise, surface evaporation would increase. Greater dehydration would occur in the inland areas. The region of heaviest impact would be on the broad grain belts of the American Midwest, where soil moisture could be reduced by 50%. Moreover, according to Dr. Manabe's computer simulation, the influence could spread across the whole Earth. Most regions in the Northern Hemisphere, except for India and Southeast Asia, would become drier. Prime agricultural regions in China, the Soviet Union, and Europe would be greatly affected. It's estimated that the productivity of these vast farming areas would be reduced by 20%. At NASA's Ames Research Laboratory near San Francisco, scientists are monitoring the changing nature of the Earth's atmosphere. Regular flights are made into the stratosphere to sample the ozone levels in the upper limit of the atmosphere. Developed as a military reconnaissance plane, today this U-2 serves the purposes of science under the designation ER-2. Once the ER-2 leaves the ground, it climbs at an angle of 60 degrees. The plane has long, glider-like wings, enabling it to fly in the thin, high-altitude air. The view from the cockpit at 12 miles above the Earth is extraordinary. Outside, the temperature is 132 degrees below zero. The blackness of space borders the ethereal blue of the Earth's upper atmosphere. Life cannot exist here. But this portion of the stratosphere is crucial to the existence of life on the continents below. This realm on the edge of space contains the ozone shield, which protects the surface of the Earth from deadly ultraviolet radiation. In the early days, the Earth was without an ozone layer. For 3 billion years, the land was directly exposed to strong ultraviolet bombardment. Because ultraviolet rays destroy the materials necessary for reproduction, early life was restricted to the sea. Every organism, no matter how primitive, contains DNA, the genetic blueprint of life. The fragile DNA structure is destroyed easily when exposed to ultraviolet radiation. Early in the Earth's history, the waters of the oceans were the only barrier that protected this vital structure from the radiation. Therefore, the first living creatures were restricted to the water, and the continents remained desolate. The development of oxygen-producing organisms gradually brought about dramatic changes on Earth. Over billions of years, they released a great amount of oxygen into the water, which gradually dissipated into the air. As oxygen in the atmosphere increased, some of it reacted with ultraviolet light to create a layer of ozone in the upper atmosphere. By absorbing ultraviolet rays, the ozone layer made it possible for life to emerge from the water onto the land. Over the last 2 decades, a rapid change in the Earth's ozone layer has prompted increasing concern in the world's scientific community. At the University of California, Irvine, Professor Sherwood Rowland has been studying the effect of synthetic gases on the ozone layer. Collecting air samples from around the world, he analyzes them for chlorofluorocarbons, or CFCs as they are called. CFCs are a class of inert compounds commonly used as refrigerants, aerosol propellant, and solvents. Because they are not broken down in the lower atmosphere, CFCs eventually rise into the stratosphere. There they are broken down by sunlight, releasing chlorine. This chlorine in turn triggers a chain reaction that destroys large amounts of ozone. The equation is simple. The more CFCs, the less ozone. Rowland's air samples come from places as diverse as the languages which mark their labels, but they all point to the same conclusion. Concentrations of CFCs are increasing throughout the world. Even in the Arctic and Hawaii, far from the great cities and industrial areas, levels of these gases are steadily rising.
The ozone layer, although it does this protection for us, is really very thin. It's only about 3 parts in 10 million of the atmosphere are ozone. It's a very trace species, and it is formed all the time and it is destroyed all the time. It's really very fragile. If we add other species which can attack the ozone layer, then we can easily change the amount of ozone that's in the atmosphere above us. The chief threat to the ozone layer in the present time is the release of chlorofluorocarbon molecules to the atmosphere. This means fluorocarbons 11, 12, and 113, which are used as aerosol propellants in refrigeration, and in the case of fluorocarbon 113, the cleaning of electronics components. And the solution for this is that we should quit putting these molecules into the atmosphere. We need to find substitutes for all of them.
Data from the Nimbus 7 research satellite indicates ominous changes occurring in the ozone layer over the South Pole. These images represent fairly normal ozone fluctuation until as recently as 1981. But during the early 1980s, changes became visible. The pink area in the center of the screen appears and continues to expand from year to year. The pink represents low ozone levels above the polar continent. Many scientists are alarmed at how rapidly the ozone hole has expanded. A significant change is apparently occurring in the Earth's atmosphere. It took over 2 billion years of evolution for primitive sea creatures to help create the oxygen-rich atmosphere we breathe today. Another billion years passed before there were land plants. Today, forests are among the major sources of oxygen in the atmosphere and are therefore vital to the ozone barrier. But today, both the forests and the barrier itself are under attack. The tropical forests are falling to widespread logging and continuing slash and burn agriculture, while the ozone layer is being depleted by human activity through atmospheric pollutants like chlorofluorocarbons. But like the ancient civilizations of Egypt and Ephesus, our tendency is to ignore these problems. It's easier to find new environments that will house us. In the Arizona desert near Phoenix, there is a unique community. This is Sun City, home to nearly 50,000 people. A marvel of modern engineering, Sun City offers all the amenities of contemporary civilization in the midst of a hostile environment. It rarely is cloudy and almost never rains, and yet the city remains green because of tremendous amounts of water that are constantly pumped in. The natural temperatures frequently soar into the hundreds, but indoor air conditioning keeps residents cool. But despite its contemporary design, Sun City is an expression of one of the most ancient of human aspirations. This is the desire to control and modify the environment. The villages and farms of the Middle Ages were carved out of the vast woodlands of Europe. Now this city is spreading out into a hot and treeless land. But without the continued use of great amounts of energy, the desert would soon reclaim this man-made oasis. Sun City is an example of the technological power of modern civilization. But it's also an expression of the vulnerability that we have never been able to leave behind, even when we escape the planet. We have ventured into space, sent probes to the farthest reaches of the solar system, and even walked on the moon. Already the dream of building colonies in space, which was once considered the stuff of science fiction, is close to becoming a reality. And yet space does not offer a good alternative to our home planet. It may be the last frontier, but space is hardly a welcoming environment. In practical terms, it is a vast and hostile place, where the slightest technical failure means death. The only welcoming world we know is this one, the planet Earth. Over billions of years, Earth has become a world of vast and intricate systems, of dense forests and barren deserts, of volcanic heat and glacial cold. The Earth is teeming with 1 million forms of life that have helped shape the very nature of our world, from the land under our feet to the air we breathe. The natural rhythms of the planet are beautiful and sure. Mountains rise, cool rains fall. Glaciers come and go in cycles as simple as the dawning and the setting of the sun. We are the custodians of this magnificent Earth. We must use all our ingenuity to treasure and protect it. This is our home, the miracle planet.
Funding for the Miracle Planet was provided by Bull Worldwide Information Systems, unleashing the power of computers for customers on 5 continents.
And by Amoco, fueling the American dream for the year 2000 and beyond. And by viewers like you. The Miracle Planet is available as an educational package. To order, call 1-800-843-0048. This is PBS.
Hello there, Harvey here again. We hope you've enjoyed this fine program made possible by your support and in part by WMGK. That's Magic 103, where you'll find me, Harvey, in the morning. Makes sense. See you on the radio.
Some people hustle pool, some people hustle cars. But have you ever heard about the man who hustles stars? Jack Horkheimer, Star Hustler, director of the Miami Space Transit Planetarium.
Our episode for this week, Monday, February 19th through Sunday, February 25th, is how to find a tiny green sky cloud that'll knock your socks off.
And now here to tell you all about tonight's sky and the biggest show of all, the universe, your Star Hustler, Jack Horkheimer.
Greetings, greetings, fellow stargazers, and this week we're going to use the 3 belt stars of Orion the Hunter to find our way to an absolutely magical, mind-blowing spot in the heavens. A spot that has tricked the eye for thousands of years. A cosmic spot of true celestial wonder. To find it, all you have to do is go outside any clear night during the month of February between the hours of 8 and 10 p.m. your local time and look south. And there, right in front of you, you'll see 3 equally spaced stars in a row, the belt of Orion the Hunter. But if you look very closely here, on a night when there's no bright moonlight, you will be able to see 3 additional and much dimmer stars, also almost equally spaced in a row, hanging down in a straight line from the belt stars. And it is the middle star of these 3 stars which we're going to zero in on, because the middle star of these 3 stars is not a single star at all, but is in reality a stellar nursery, a place where stars are being born. Indeed, if you take even the cheapest pair of binoculars and look at this middle so-called star, you will find that it is not a bright, sharp, crisp, pinpoint star like the others, but instead appears to be a very fuzzy object. It looks kind of like an eerie, pale green, tiny wad of cosmic cotton, a celestial Q-tip, because this is not a star at all, but what astronomers call a nebula, the Great Nebula in Orion the Hunter. A French astronomer named Messier labeled it M42 because it was the 42nd sky object in a special list he compiled. And today, astronomers officially call it M42. I, however, still prefer to call it the Great Orion Nebula. Now, some people have such acute eyesight that they can even tell that it's a fuzzy, cloud-like object and not a sharp, star-like object with just the naked eye. And even the cheapest binoculars will show you a great cosmic cloud here. If, however, you have a small department store telescope and first start with low powers and then build up to high powers, you will notice that this great nebula is very large, 6 light years wide, much, much larger than any single star. In fact, you will even be able to see several stars embedded within it, stars which are very young and new, astronomically speaking, stars which may be only a few 100,000 years old. I especially like to look through a small telescope at the 4 stars in the middle of the nebula that look like they're laid out in the shape of the 4 bases of a baseball diamond. In fact, these 4 stars together are called the Great Trapezium of the Orion Nebula. And might I recommend that if you don't have a small telescope of your own, by all means look through a friend's telescope or visit your nearest local amateur astronomy club's observatory, because it's a sight you will never forget. And with that, may I simply say, head out under the night sky to find a fuzzy star, a fuzzy object which will actually sharpen your perception of the universe, if you just remember to keep looking up.
Star Hustler, made possible by grants from the P.L. Dodge Foundation, the Miami Space Transit Planetarium and Museum of Science, and the Abraham Schwartz Memorial Fund.
Channel 12 now concludes its broadcast day. Channel 12 is a nonprofit educational television station serving the people of the Delaware, Pennsylvania, and New Jersey communities. Channel 12 has studios at 5th and Scott Streets in Wilmington, Delaware, and 150 North 6th Street in Philadelphia, Pennsylvania. The Channel 12 transmitter operates at a frequency of 204 to 210 megahertz and is located in the Roxborough section of Philadelphia, Pennsylvania. Channel 12 transmits at a maximum power of 309,000 watts by authority of the Federal Communications Commission. Channel 64 broadcasts Channel 12 programs for southern Delaware. The Channel 64 transmitter operates at a frequency of 770 to 776 megahertz and is located in Seaford, Delaware. Channel 64 transmits at a maximum power of 191,000 watts by authority of the Federal Communications Commission.